Good afternoon, ladies and gentlemen. We are going to be starting. Can I please ask for all of you to take your seats? A very warm welcome to all of you, and welcome to the grand finale of the Liveability Challenge 2021. My name is Jessica Chiam. I'm founder and managing director of EcoBusiness, and I'm delighted to be your host today. We're just about to begin, so I'd like to request that you get comfortable and turn up the volume. Our sustainability event of the year will now be kicking off with a welcome video, specially produced for you. Enjoy.
By 2050, global carbon emissions must reach net zero to keep temperatures within a 1.5 degrees Celsius rise from pre-industrial levels. Scientists regard this as critical to prevent the worst effects of climate change. With more than 50 billion tons of carbon emissions released into the atmosphere every year, we need revolutionary ideas and technological innovation which will enable humanity to drastically reduce emissions and its removal at scale. At the same time, our modern disposable culture has accelerated resource scarcity and created a pollution crisis that threatens the natural ecosystems which we depend on. We need a circular economy to replace our current linear production model, which is hugely wasteful and pollutive. How can we find solutions which are restorative and regenerative in design? This year, the Liveability Challenge is searching for ideas in decarbonisation and reimagining resources to build sustainable cities in the tropics.
We are looking for game-changing deep technology innovations that will address climate change issues.
Well, I hope that video got all of you excited, especially when you felt the vibrations in the room. And although you can't see my face because I'm behind the mask, I can assure you it definitely gave me the excitement. On behalf of Temasek Foundation and EcoBusiness, I'd like to welcome everyone again, both our in-person guests who have joined us here in the studio, and also to all of you who have joined us virtually. We are live streaming this grand finale of the Liveability Challenge 2021 from Marina Bay Sands in Singapore. This event is also being broadcasted on Facebook Live, and even though the COVID-19 regulations has made it difficult for us to interact in person, we would love for all of you to engage with our community on this special afternoon and show your support for our teams by sharing your thoughts on our platforms and in your networks. The Liveability Challenge, or TLC as it's affectionately known, is now in its fourth year and is being presented by Temasek Foundation and organized by EcoBusiness. Over the years, TLC has grown from strength to become Asia's leading sustainability solutions platform, whose single purpose is to support startups from all over the world make their sustainability ideas a reality. We search the world for the best ideas, we help incubate and fund them, so they can scale their solutions and help humanity tackle some of the most difficult challenges that we face today. I remembered that this time last year, we hosted this finale under lockdown conditions, and we live streamed it for the first time. And we had hoped that by this time this year, we would have been able to host our event to the original scale. But as COVID-19 continues to ravage the world in unexpected twists and turns, we've also continued to witness the increasingly visible effects of climate change. In the past few months, we have all seen the spectacular scenes of destruction that has played out across the world. From the flooded villages in Germany and the subways of Zhengzhou, to record temperatures in British Columbia and Serbia, to the widespread death of marine life in the Pacific Northwest. The world feels at risk, and indeed, we are. Large parts of the tropics, where we live, risk becoming too hot for outdoor work. Natural ecosystems and jobs that depend on them will disappear. Food security will be threatened. Sea levels will continue to rise. But even as we grapple with COVID-19, this climate crisis is marching on. This is why we need to be urgently looking for solutions that will help us reduce carbon emissions at scale, to help us adapt, and to help us to move to a circular, regenerative economy. While humanity is responsible for destabilizing the climate, we can also be the ones to solve it. And we need the capital to make this happen. This is why TLZ exists. Over the past year, TLC searched the world for the best ideas. And despite the pandemic, we attracted more than 400 quality submissions from over 60 countries. We then had 19 judges, some of them in the room with us today, across 2 steering committees to assess all the submissions and to identify the final teams who have made this grand finale. Today, the teams will pitch their game-changing ideas to our grand finale judges to vie for the grand prize of $1 million and other funding opportunities. We have with us here today 5 established names in the investment community, and I'm delighted to introduce them now. 4 of them are here with us in the studio. First up, we have Mr. Lim Hock Chuan, Chief Executive of Temasek Foundation Ecosperity, the organization that has made this entire initiative possible. Temasek Foundation is a key player in the sustainability space, enabling innovators to take their ideas from laboratories to the marketplace. They are providing the grand prize of $1 million today. And next to him is Mr. Steve Malawish, impact investor and a well-known entrepreneur behind Property Guru, who recently started Planet Rise, an impact investing firm looking for climate solutions. Planet Rise is going to be upping its investment price and is going to be offering an investment of $100,000. We also have with us Ms. Patty Chu, co-head impact investment at Strand Capital, a family office which invests in regenerative agriculture and other nature-based solutions and is offering a $50,000 investment. Next to her is Mr. John Kim, co-founder and managing partner of AirAsia, a VC firm which invests in companies that catalyze behavior change for a more sustainable planet, whose award is $50,000. And last but not least, joining us virtually all the way from Geneva is Ms. Alice Charles, project lead of the Cities Infrastructure and Urban Services Platform at the World Economic Forum. Thank you so much, Alice, for joining us here today, even though it is so early for you. Now, I'm excited to be introducing the finalists of the Liveability Challenge 2021. Featuring in the grand finale this year are Econic, SEPPURE, Aegis Packaging, SeaChange, Divi Gas, and New Battery Materials. Also backed by popular demand, we will be launching our audience poll where you get to vote for your favorite team. This poll will be launched on our virtual platform as well as Facebook. And for our in-person guests, you can scan the QR code to your left and right of the stage. We will be closing this poll when all the finalists have finished their pitches. Now, to start us off today, it is my pleasure to introduce our first team, Econic from the United Kingdom, who will be presenting their solution, which turns waste carbon dioxide into useful polymer products. Dr. Michael Kember, thank you for joining us so early from the UK. Over to you.
Good afternoon. I'm Dr. Mike Kember, co-founder of Econic Technologies, and I'm proud to be here today to tell you about our process to transform CO2 from waste to an opportunity. Econic offers a ready-now catalyst and process technology that transforms captured CO2 into a wide range of valuable everyday products. Our technology, coupled with existing polyol manufacturing infrastructure and CO2 point sources available at Jurong Island, together with Singapore's ambitious Green Buildings Pledge, can be a catalyst for global change towards better polymers and cities. There is an urgent need to reduce our greenhouse gas emissions. We need to capture CO2 instead of emitting it to create a circular economy. And Singapore is well poised to take a lead in this area due to the high concentration of emissions from energy and industry. Carbon capture and storage has struggled to gain widespread adoption because it's expensive and it doesn't create value. Carbon capture and utilization is a much better approach, as it treats CO2 not as a waste, but as a valuable raw material for everyday products that society needs. The scale of global emissions means that we need a cumulative approach to CCU. But the challenge is that most technologies are not currently market ready, economically viable, or they require access to clean energy or hydrogen that just doesn't exist today. So we need a ready now solution to kickstart carbon capture and utilization. Econic's patented catalyst technology produces existing necessary polymer products with a reduced carbon footprint by replacing up to 50% of current raw materials with captured CO2 from nearby energy or industrial processes. The final products are not single use. They have a wide range of long life applications, many of which can be recycled. Our first target market is in polyols, vital ingredients for polyurethanes, which are versatile materials used in essential products as diverse as mattresses, car seats, home insulation, sportswear, and even roller skate wheels. In particular, this project will focus on insulation foams, vital in increasing the energy efficiency of our cities by reducing the energy requirements for building temperature regulation. This makes them a perfect fit for tropical climates such as Singapore. Our technology offers benefits in three main areas for both polyol producers and consumers, based upon environmental, technological, and economic performance. For polyol producers, up to 30% reduction in CO2 emissions is achieved with our technology, and complete adoption across the entire polyol market would be more than 11 million tons of CO2 savings per year. But we're targeting a more widespread adoption across polyols, surfactants, and polymer products by 2035, which would be more than 50 million tons per year of CO2 emission savings. Additionally, long lifetime applications, such as insulation foams, can save further billions of tons of CO2 emissions through energy efficiencies. And polyurethane insulation foam is ideal for retrofitting onto existing buildings, which makes it a perfect fit for Singapore's 2030 Green Buildings Pledge. Our technology has been developed and matured over 10 years in response to market feedback. The polyol materials have been tested in end-user trials, verifying their performance and the benefits to the customer. The process technology has been defined and validated through an engineering definition and review project in partnership with a global engineering provider. The technology is ready now for commercial adoption and scale-up. Carbon dioxide offers enhanced performance in all polyurethane applications that we've tested, including these benefits listed specific to insulation foams, such as reduced smoke emissions and flammability, vital in construction applications. Our process does not rely on carbon credits for profitability. Replacement of oil-based raw materials with low-cost CO2 provides savings of up to 30%, making the polyols cost competitive with traditional technologies. Furthermore, CO2 enhances the technical performance and provides opportunity for value creation for introducing these polyols into higher value performance markets. Econic enables existing producers to retrofit our technology onto their current manufacturing plants, creating revenue through catalyst sales and process licensing. This business model is only available to us through the unique low-pressure operation of our catalyst and technology, which gives us a low capex entry into market, with a return on investment for a typical plant expected within less than 2 years. In contrast, other catalyst technologies require high capex, new, high-pressure plants for operation. The intermediate polyol material produced by our direct customers is sold on to downstream users such as brands and formulators who will create the final PU products that benefit consumers' lives. We're expecting top-tier profitability for our investors, and business plan states EBITDA margins of more than 50%. Our Liveability project overcomes barriers to commercial adoption in a conservative and heavily regulated supply chain. This will accelerate our entry into the market, bringing forward revenues and the timeline to profitability for the company. Work Package 1 will focus on completing pilot polyurethane application trials with partners, including Asia Polyurethanes, enabling product validation, accreditation, and market generation. Work Package 2 will fund design work with engineering providers to establish plant design and CapEx costs, as well as suitable CO2 source and capture technology for integration with the plant. These two projects together will create a compelling business case for the CapEx needed for the first commercial scale production in Work Package 3. And we're currently discussing partnership for this phase in confidential conversations with a number of polyol producers. Introduction of our technology into Singapore can secure a springboard into the rapidly growing Asia market, which currently accounts for 50% of a global $28 billion polyol market. We have a talented and experienced team to deliver this project, including our CEO, Keith Wiggins, responsible for commercial negotiations, myself and Anthea Blackburn, who will manage the application pilot projects, and Dave Walker, our head of process engineering, who coordinates the engineering projects. Econic offers ready now decarbonisation solution that is perfectly aligned with Singapore's existing industry and infrastructure. By using waste CO2 to make everyday consumer products more sustainably and buildings more energy efficient, Singapore and cities around the world will be well on their way to reaching their net zero targets. Thank you for listening.
Thank you very much, Michael, for your presentation. We will now be moving into the question and answer segment, which is going to be strictly 7 minutes for all teams. And I now perhaps like to invite Patty to pose the first question to Michael, who should be coming up shortly.
Hi, Michael. Can you hear me?
Yes, I can hear you fine, thank you.
Great. Yeah, my first question is related to your business model. So I think you mentioned that it's partially the sale of the catalyst itself, as well as licensing technology. So I think I understand the catalyst, the sales of the catalyst product. Can you tell me a little bit more about the licensing structure?
Yeah, sure. Our main revenue will be through catalyst sales, but to enable use of the IP, to enable the catalyst to work in plants, we will sell a license to our technology, an initial license to build a plant, and it will be plant specific as a one-time fee. The catalyst sales will ultimately make more than 90% of our revenues.
Thanks. Can you tell me what exactly this catalyst is made of? I guess this is your IP, right, as well?
Yeah, our IP is the catalyst, the process to use the catalyst and the products that it makes. It is a fine chemical that we manufacture through outsourcing to standard fine chemical manufacturers, and we can in fact recycle it completely by removing it from the product and then reprocessing it and reusing it.
And the catalyst has to be used in conjunction with carbon dioxide. How does it typically work? Like, where do the polyol producers at sources? Is it from their own production, or does it come from somewhere else?
Our catalyst is robust to many different sources of CO2, so polyol producers have options. Ideally, it comes from a locally sourced industrial emission. For example, in Singapore, there are ethylene oxide produces a very clean and concentrated source of CO2, and there are other emission sites nearby that also would be appropriate.
And is this, the polyol sort of product, it's also counting on still oil-based feedstock, right? I think in some of the information that I received, there's also, I guess, the strategy of creating other products that are they non-oil kind of derivatives, or that can be in conjunction be used with your catalyst product to create other things. I think there was, I read something about textiles and something about wind turbines. Can you tell us a bit more about that?
Absolutely. Initially, our process works with the existing industrial feedstocks, which are oil-based. There are bio-based routes to some of those feedstocks, for example, ethylene oxide, which is heavily used in surfactants. There are industrial processes to make bio-based ethylene oxide currently being scaled up. But further, our technology is robust and can be used with a wide variety of bio-based raw materials to create new polymer products. For the textiles industry, we would be using the current process technology and the existing raw materials, but it would offer initially substantial CO2 savings in the application compared to the current materials. When you use the technology in other applications such as insulation foams, refrigerations, or in lightweighting of cars, you can create further carbon savings by the life cycle of the materials, creating energy efficiencies.
And in your clients, in addition to, purchasing the IP and your catalyst, they also need to make quite substantial, retrofit or capital investments to. Is that a correct understanding? And yeah.
Yeah, absolutely. So the capex that they need to retrofit their plants is single-digit millions. So for a chemical plant, that's very low, and we anticipate return on investment in less than 2 years. If we compare this to competitive technologies which operate at much higher pressures, they need a new build plant, and we're talking, $50, $100 million dollars for building a new plant. So comparatively, the investment is very small.
I think you elaborated that you've already in discussions with a number of companies here. So with or without, the price of this, would you still be looking at Singapore and Asia as a market?
Absolutely, yes. Singapore is the perfect location to introduce our technology. All of the supply chain exists on Jurong Island, so there are CO2 point sources, there are existing raw materials production, supply chains, polyol manufacturers and polyurethane systems houses, as well as a forward-looking attitude such as as seen in the Green Buildings Pledge. Asia itself is also the largest and fastest growing market for polyols and polyurethanes. So when you combine the two, yes, absolutely, this is a perfect opportunity for us.
Thank you. We have 1 minute and 20 seconds left. Any of the other judges would like to ask Michael a question? Any of you? John, go ahead.
Yeah, just thank you, very impressive. Just curious about how far you are from commercialization. I know you mentioned some pilots. How demonstrated is the technology now versus where it needs to be before you can get out selling this at a large scale?
So the technology itself is now ready. We have demonstrated the catalyst at quarter-ton scale. We've demonstrated the process on multi-kilo scales with our small demo plant in the UK. We've had an external engineering provider do a definition and review project, which has defined the technology. It's essentially ready to take it up to the ton scale and beyond. And what we need now is what this project will aim to achieve, which is market demonstration at the ton scale, so producing materials and polyurethane pilot tests at the ton scale to get market accreditation, and the final engineering design for a larger scale plant. And that's what this project will achieve.
Thank you very much.
Just one quick follow-up question. So you mentioned low single-digit millions for the CapEx, and then a 2-year payback period. How does that work in terms of, is that based on the margin of what they're getting after the costs of catalyst and licensing?
It's based upon margins. It's based upon increased process efficiency and larger volumes being produced from the plant, and obviously lower raw material feedstock costs.
Okay, great. Thank you very much.
Thank you very much, Michael.
You're welcome.
Thank you very much, John and Judges. Patty, time is up, so I would now like to thank Michael and move on to the second team.
Thank you.
Thank you. I'm now delighted to introduce SEPPURE on their sustainable solvent recovery and nanofiltration technology. We have Dr. Mohammed Farahani dialing in from Canada. Over to you.
$3.6 trillion is the cost of energy we use in chemical separation processes every year. It's equivalent to 15% of the world's energy consumption. We're using a massively energy-intensive process called distillation to separate solvents from the products that we use every day, such as vegetable oil. Distillation simply works by heating and cooling, and the fossil fuel we burn for the heating emits more than 10% of the world's carbon emissions. Distillation also consumes 1.2 trillion liters of water in the heating and cooling process. The problem doesn't end here. We use billions of liters of solvents in the industry. However, less than half of these solvents are recovered because existing recovery methods are not so economical. This results in disposing $20 billion worth of solvent, and the number is growing. SEPPURE is changing that. We are the sustainable closed-loop solution to solvent recovery and reuse. We're replacing the driving force of the separation from thermal to mechanical. We pump chemical mixtures through our patented chemical-resistant nanofiltration membranes, and its nano-sized pore selectively separates chemicals at the molecular level. In fact, by removing the use of heat, our technology reduces the energy consumption and carbon emissions by 90%, while making the process 50% more economical compared to distillation. We have an ROI of less than 2 years. By replacing only 10% of the distillation globally in 10 years, SEPPURE can save $180 billion in operating costs and enough energy to supply Singapore's electricity for 25 years. We can reduce 500 million tons of emissions and save 40,000 Olympic-sized swimming pools of water every year. Moreover, our technology promotes a circular economy. Our membranes enable solvent recovery and reuse, promote sustainable manufacturing of various products. Even at its end of life, our solvent-resistant membranes can be recycled into fire-resistant fabrics. We have developed our technology for more than 6 years, and SEPPURE's membrane was born during my PhD at the National University of Singapore. And at SEPPURE, we've taken this technology to another level. Altogether, we have optimized our product based on more than 80 membrane formulations, produced over 800 kilometers of hollow fiber membranes in-house, and fabricated and tested more than 2,000 membrane modules. And we have 10 industrial projects with some of the biggest names in the industry. The results of our intensive R&D are protected by 2 patents and a lot of technological know-how. SEPPURE's technology can be applied in many applications in growing markets like vegetable oil, biodiesel, semiconductor, petrochemical, pharmaceutical, and oil and gas. Our current focus is vegetable oil industry. Our technology is ready to be implemented in vegetable oil production, refining processes, and biodiesel production from used cooking oil. We have a huge traction in vegetable oil market with several flagship projects. We completed a pilot with a local vegetable oil company, and 3 pilot projects are ongoing with the world's largest vegetable oil companies from Japan, United States, and Canada. We have already received a 6-digit revenue from them. In other industries, such as semiconductor and energy, market leaders are testing our membranes in field. From our humble base in Singapore, we oversee projects across 4 continents. We have over 150 plants in the pipeline to achieve $500 million in revenue. We have a huge potential addressable market of $10 billion, and our projected CAGR is over 200% for the next 5 years. SEPPURE membrane is the winner when it comes to the competition. Our membrane is 20 times faster than the market leader, and we have 3.7 times higher packing density compared to all competitors because of our unique hollow fiber configuration. In other words, it takes 1 SEPPURE module to complete the same job as 74 Econic modules. We provide the complete solution package from membranes to systems. We work at the intersection of membrane technology, process engineering, data analytics, and machine learning. To sell our membrane technology, SEPPURE will work closely with OEM partners. The industrial system will be designed by SEPPURE and manufactured by an OEM partner. SEPPURE will be manufacturing and selling its membrane module, creating recurring revenue. After 6 years of R&D, we are making commendable progress at commercialization. Next year, we will be doing our in-field implementation with an industrial partner and launching our product to the market. In 2023, we will be launching our digital solutions focusing on the use of machine learning and AI for membrane design and predictive maintenance. SEPPURE is already partnered with NUS and ASTAR for this machine learning project. From 2024, we will be launching SEPPURE gas technologies for hydrogen purification and carbon capture applications. We have completed a successful pilot with a Singapore-based vegetable oil producer and 2 other projects on their way towards in-field implementation. With the $1 million funding from Temasek Liveability Challenge, we will be able to implement the world's first industrial membrane plant for solvent recovery in vegetable oil in Singapore. This in-field implementation is the most important and the last step towards commercialization of SEPPURE product. This is not only well aligned with Singapore's Green Plan, but also the country's goal for sustainable food production. I am Mohammad Farahani, founder, CEO, and CTO of SEPPURE. I received Innovators Under 35 Award from MIT Technology Review for developing SEPPURE's technology. Our technology management and business development team have over 50 years of combined industrial experience in membrane scale-up, production, and commercialization. And our advisory board, we have Professor Neil Chung and Professor Kranz, 2 of the world's top membrane scientists in the world. SEPPURE is the future of sustainable chemical separation. Our team worked hard to enhance the livability in Singapore and globally by enabling industries make great products we use every day without destroying our valuable resources. You can be part of our mission to create a more livable Singapore. Thank you so much.
Thank you, Sapio, for your presentation. We will now move into the question and answer, and joining Dr. Farahani is actually Dr. Hafiz Osman, who is here with us in person. Dr. Hafiz, please join us on stage. I believe our judge, John, has some questions to begin with. John, over to you.
Thank you very much for the presentation. It's very impressive. First, I guess, if you could just double click a little bit on the technology. So I'm not an expert in membranes or nanotechnology. Just from the pictures, it just looks like the holes are a certain size, so certain molecules can get through and others cannot. Is that sort of too simplistic a way of looking at it? Could you just help explain to a layman?
Thank you so much for this opportunity. First of all, I wanted to be in Singapore, but because of a project, I'm currently in Canada. But I think we're enjoying your time in such a big event there. So regarding your question, so the membranes are basically made of polymeric materials. And the whole surface of the membrane, the straw type of the membranes that you have seen, the hollow fiber, the whole surface area outside is basically the selective layer, having pores with less than 1 nanometer in size, in diameter. So that's basically where the molecules should pass through. And the inside of the membranes is hollow. So the liquids that actually pass through the pores of the membrane goes into that tiny hollow fibers and will be separated.
Got it. And I saw in the presentation that you had 10 industrial-sized projects, but then you mentioned some pilots. So are the pilots these industrial-sized projects, and does industrial-size mean sort of the types of deployments that you hope to get with these $500 million of revenue in the pipeline?
So I mentioned industrial projects, so which means that we are doing this project with industries and we're using real industrial feed. So some of them are basically based on our lab in Singapore, that we are getting samples from industry and doing the pilot with them. For some of the projects, we are sending our membranes to their basically facilities, and they're running the pilots in their plants. So we have customers in the US, in semicon and energy, that they are testing the membranes. We have some customers in Canada that we send them the membranes and they're testing in field. But we have some local companies in Singapore that we're working with them based on our lab in Singapore.
Got it. And so the ones in Singapore, you're working with they're coming to the lab to do samples, or I guess my question has to do with the fact that when you're not on premise, sort of the deployment and sort of even the collecting the data and the installation sometimes is a little bit more difficult when there's hardware involved. So I would imagine in the US it's possible, but just maybe a little bit more involved if it's overseas. Have there been any of these pilots that you've sort of been able to oversee and actually kind of install and get the data from directly?
Yeah, so the Singapore ones that currently we are doing, so basically it's happening in our lab. So we have a pilot system and we are receiving the samples from the industry and we are running the pilots in-house. So we have three-phase projects with most of our customers. So the first phase is the pilot. The second phase that we hope to actually complete it in early next year and starting like end of this year is the in-field implementation. That's why we want this Temasek Liveability Challenge award in order to enable us to install them in field. And that for the first project, we're targeting one of the refineries that we already completed a pilot with them in Singapore.
Got it. And so this would be the first in-field implementation.
Implementation, yes.
Got it. Okay. You mentioned AI. I mean, that's quite interesting. Yeah. How does that help with membrane design?
So yeah, so we have we are an industry partner to a project with NUS and ASTAR that basically uses the data, whatever data is already published in the papers and whatever data we're obtaining in-house to help us to design the membranes that are specifically good for certain applications. So without going through all these experiments. So basically with giving like some information to that model, we can actually find out which membrane, how we're gonna make that membrane.
Okay. And then I also saw something, I guess the AI as well as the some of these other mentions for a little bit further down the line. There's something about sort of using the technology for other applications like carbon capture. So how would that work using membrane technology?
Yeah, so currently our focus is on vegetable oil and chemical resistant membranes, but based on the same platform, same type of material we have, and it's protected by our patent, we are going to release our gas separation membranes in 2024 onwards. And that gas separation membrane is going to be able to basically do the carbon capture from natural gas or from other sources, as well as hydrogen production.
Okay, got it. So then bringing it back to sort of today, once you get this implementation in field, and it'll be vegetable oil, which is your first use case.
Yes.
Then you can go out and start selling it for more in-field applications and deployments. How do you think about your go-to-market there? I understand you're sort of selling to vegetable oil refineries. Is that correct?
Yes.
And then specifically, who in those refineries is the decision maker that you're selling to? And then how do you think about building out the go-to-market team, sales, BD, and so forth? Who's doing that currently? And then what do you need to sort of fill to plug that gap?
Yeah, so we'll start with a short answer and I'll pass it to Hafiz. So currently we work with the managing directors and the directors of R&D in all these companies we are working. So, and they're like multi-billion-dollar companies. And the reason that we engage, these high-level people is because they see the immediate need for replacing their distillations, the membrane technology. But for the second part of the question, I would invite Hafiz to answer that.
Yeah, I mean, if you think about it, we are at the similar time and place as we are 40 years ago when membrane technology was introduced into the water desalination, right? So in the exact time and place there. And we are running out of time. So,
yeah, so basically,
what is the question?
we can actually, for the business development, currently we have Hafiz in the team, and I'm going to actually create a sales team once we go to manufacturing next year. So we have planned to start manufacturing our membranes next year.
Great. Thank you very much. Appreciate it.
Thank you.
Thank you. We have 5 seconds left, so I'm afraid the other judges, you don't have any time to ask questions. But thank you so much, Sapio, for your answers, and thank you very much, judges, for your questions. Can I invite you to take your seat now? Thank you. All right. For our third team this afternoon, please welcome Dr. Gaurav Sant and Kamli Tan from SeaChange, who are dialing in from the United States. They will be sharing their idea for atmospheric carbon removal at the gigaton scale. Over to you.
Hello, I'm Kamli Tran, and my partner Gaurav Sant and I are part of a team called SeaChange. We're proposing a solution to tackle one of our greatest threats, climate change. Climate change is the single greatest threat to a sustainable future, and yet, addressing the climate challenge presents a golden opportunity to promote prosperity, security, and a brighter future for all. SeaChange leverages the oceans for massive carbon removal by using nature as its inspiration. In nature, sea corals and mollusks capture CO2 simply by making their seashells and exoskeletons. This process can be mimicked synthetically and stimulated by using electricity. SeaChange uses electrochemical reactors to mimic this process, which converts the CO2 dissolved in the ocean's water into solid mineral carbonates. These are inert, durable materials like crushed seashells. By removing the CO2 in the seawater, we allow more atmospheric CO2 to redissolve or reabsorb in the ocean's waters, thus reducing the accumulation of CO2 in the atmosphere. Why do we need transformative carbon removal? Well, there are current challenges with carbon management solutions today, both at the large and smaller scales. For carbon capture and sequestration, there are unknown risks with long-term CO2 leakage and no possibility for end products. With direct air capture, the CO2 concentration in the atmosphere is low and requires the compression and transportation of CO2, which is expensive and lacks the infrastructure today. And waste carbon utilization often requires upfront costs involving separation and purification with unfavorable economics. While all of these solutions will play a role in combating climate change, SeaChange fills the gap of large-scale and durable removal of CO2 and produces value-added products along the way. Our solution converts the dissolved CO2 in water, which is 150 times more concentrated than air, into stable benign carbonate solids that permanently immobilize CO2 for thousands, if not millions of years. Why should you believe in SeaChange? Using seawater as a sponge unlocks game-changing efficiencies for atmospheric CO2 removal. As dissolved CO2 is removed from seawater, additional CO2 can be redissolved into the ocean's water. What this means is we can reduce the accumulation of atmospheric CO2 at large scale by taking advantage of the massive scale of the oceans. Our process can be powered by zero carbon energy and avoids energy-intensive processes that currently exist with other carbon management strategies. By using electrochemistry, we create a water pH shift to force the precipitation of solid carbonates. The water pH remains unchanged after we redissolve rocks into the ocean's waters, preventing the potential of an environmental damage or harm to sea life. Lastly, our system can be integrated into existing infrastructure like a desalination plant or offshore platforms, and this further reduces the CapEx and OpEx of SeaChange. How does it work? It's really quite simple. Seawater flows through our electrolytic membranes, and electrolysis forces the dissolved CO2 and calcium and magnesium ions to interact, as shown in the bottom left cartoon. This reaction forms solid carbonate minerals represented as the yellow layer. The formation of these solid carbonates indicates the capture and conversion of CO2. Our process doesn't only capture CO2, but it produces value-added products. The solid carbonates that have captured CO2 permanently can be deposited back into the oceans or alternatively used for land restoration or cement and concrete mixtures. In addition to the carbonates, SeaChange produces softened water, which is water that no longer contains ions. Softened water is an important pretreatment step for desalination, and this could be used as a feedstock in existing desalination plants, which can further reduce downstream energy costs. Lastly, we produce hydrogen as a byproduct of the electrolysis of water. Hydrogen is a clean fuel that can be used to power this system or sold as the hydrogen economy continues to grow. The value-added products are important here because you can start to offset the baseline cost of SeaChange. With an unlimited resource like seawater, we can remove carbon at scales that will accomplish our climate goals. Our process is driven by energy economics. We can accomplish electrolysis-based alkalization at the lowest energy cost when comparing current amine-based capture storage. The economics are purely conditioned around the price around electricity and green hydrogen. It can further be reduced by carbon incentives that exist depending on the location of the system. Break-even costs are difficult to address, but we can project revenue roughly by assuming the price of green hydrogen and electricity. Further, if we assume that hydrogen can be sold around $3 a kilogram, we do not need to depend on carbon taxes or credits to be profitable. Our first pilot system will remove 50 kilograms of CO2 a day, and as we scale up, the cost per CO2 will decrease. The first-of-a-kind system will cost over $1 million. However, the remaining funds will be provided by in-kind contributions and our partners, the Public Utilities Board of Singapore and Stripe. These partners offer operating experiences and resources that will support the scale-up of SeaChange. Stripe recently announced that they will be purchasing SeaChange's carbon removal credits at 1,000 $370 a ton of CO2. These credits show that a market is developing for carbon removal and demonstrates the commitment to combating climate change. The winnings of the Liveability Challenge will be used to deploy the first working pilot system on PUB's facilities in Singapore. This system will be engineered and designed in the first year, with plans to build and operate in Singapore in year 2. None of this would be possible without our team. And our team consists of engineering expertise led by Gaurav Sant, Dante Simonetti, David Jaspy, Xin Chen, Shengun Ma, and Erica LaPlante. Operational and programmatic expertise led by myself, Kamli Tran, and Ed Muller, who is handling and operating the company at the moment. We thank you for watching, and Dr. Gaurav Sant would be happy to take any questions.
Thank you, SeaChange, for that presentation. We will now move on to the Q&A. Let's give Gaurav and Kamli a chance. Hi guys. And now I'd like to invite Steve to pose the first questions for SeaChange.
Hi Kamli, hi Gaurav. First of all, great presentation and very, very exciting. A big, bold...
in pilots with a couple of different industrial partners around the world.
Okay, thank you. In terms of timescales to reach, you showed a slide earlier on which had, I think, $1,500 per ton for CO2 extraction, the cost of removing the CO2. And that needs to come down to about $15 before it becomes economically viable to be able to scale it. What steps and timescales are required to achieve that? What sort of timescales are you talking about?
Yeah, so great set of questions. So our current estimate is based upon a bench scale system, and obviously there's significant economies that come from just building a larger system. So based on where we sit, we think it's about a 24 to 36 month period to really get to what we think is the steady state, near practical cost. And we think in time that will range somewhere in the vicinity of, depending on the price of hydrogen, somewhere between a couple of tens of dollars to maybe about $100 per metric ton of CO2 removal.
And sorry, what sort of timescale was that? Roughly, you estimate?
About 36 months, 24 to 36 months.
Okay. And investment required to reach that point?
So it's going to take a couple of $1 million based on where we sit right now. And we've got a bunch of partners lined up that have been supporting us along that journey.
Okay. In terms of implementation, you claim shared CapEx and shared OpEx. Can you talk a little bit about how you see the implementation process working with a system?
Sure. So what we have been doing is we've actually been working with partners where we think that they've already got some of the capital facilities in place for us to be able to do deployments. As an example, we're working with the Public Utilities Board in Singapore because they're a desalination operator. We're really trying to understand how you take these systems and actually integrate them with an existing desalination plant. This is quite an important point because with most of these systems, a large amount of the CapEx is really associated with the seawater intake. And having the seawater intake already in place and a mechanism for handling that is really important to compressing the overall CapEx that you would need to build plants of this sort.
So at this stage, do you have a view in terms of what sort of CapEx would be involved per installation?
We do have a view, of course, as you can imagine, it's a bit of an educated guess because that's all you can really do until you build the plant. But we're thinking about plants which are on the order of about 1 million tons per year of carbon removal, costing in the vicinity of about $500 million.
$500 million?
Yes.
Yeah. Okay. In the slide that you showed around economics, the revenue versus the cost slide, I think it was around 1 million tons of CO2. The economics show a heavy focus and reliance on carbon credits in that example. So I think about 2/3 of your revenue was based on carbon credits, and the carbon credits example was around $200 per carbon credit. And I guess as we know at the moment, in some countries it's hovering around 5 or so. I guess if you think about that, how do you think about the sort of the financials and unit economics?
Right. So great question, Steve. So just to be clear, we do not actually require a carbon credit. The reason that the carbon credit is actually listed there is it shows what is the incremental benefit that could accrue if you use something like a low carbon fuel standard, which we have in California, which is actually priced at $200 a ton, and how profitable that could make the business. But the simplicity of this is that the unit economics actually depend almost purely on the price of electricity and what we think is going to be the steady state price around green hydrogen into the future. So if you make an assumption around the price of green hydrogen being between about $2 to $3 a kilo, which is probably a reasonable long-term estimate, at $3 a kilo, you don't need a carbon credit for this business to be profitable.
Okay, I just had to refer to slides. I thought it was you required the CO2 credits to sort of play a bigger role in it. It's about 2/3 of the revenue. But anyway, we'll perhaps come back to that. How do you think about IP and defensibility? You talked a lot about, I guess, the concept of what you're doing, and also how simple the technology was. How do you then think about building that defensibility?
Yeah, so this is a great series of questions. So we've accumulated a large amount of IP, which is in sort of different stages of prosecution. But what I can say quite comfortably is that the IP around the reactors and the reaction engineering and the process development is actually rather strong based on the opinions that we have right now. And that being the case, I think that's sort of really where the bulk of the value is.
Right.
Speaking of the IP particularly.
Okay, so you see Singapore as the first sort of test market. Going forward, how do you think about markets and focus and priorities?
So, we think that it makes sense to sort of have a geographically distributed strategy for an obvious set of reasons. Different parts of the world are starting to think about carbon in terms of monetary impact in different ways. Obviously, there's super progressive markets in Asia. There's also progressive markets in the United States. We've had a lot of interest also from Europe. And so we think it makes sense to look at different markets with both different size, different regulatory structure, but also different capacity for carbon removal, and really build a commercial strategy that's based on sort of these three things together. Obviously, the other thing that factors into it is having partners in place that can offer the potential for scalability within a single market. So working with large corporations and, and I would say semi-governmental agencies is, I think, really the right place to start.
Okay, thank you.
Thank you, Steve. We have 40 seconds. Any other judges would like to pitch in a question? Mr. Lim, go ahead.
Hi, Graf and Dr. Kimberly. Just a quick question to follow on Steve's comments. In terms of your revenue model and so on, I presume the figures there is done in the context of something like a desalination plant, where the bulk of the cost of seawater intake is being already covered by existing facilities. If you were to build a fresh standalone facility purely to do what you're doing, how does the figure come out? Is it still viable financially or commercially?
Yes, so it is. It continues to be viable. So the $500 million number that I laid out assumes that we would need to build all of the CapEx that is needed to actually build out our own seawater intakes. And so that's sort of the conservative scenario. If you imagine that you start to actually co-link with a desal operator or a power plant, the costs that are essentially what are outside the battery limit, so to speak, actually come down. So the total cost would actually come down quite a bit. About 30% of the cost is embedded in the seawater intakes and sort of the associated infrastructure.
Thank you very much. I'm afraid our time is up. Thank you so much, SeaChange, and thank you so much, judges. We're going to have to move on to our next team. For our fourth team this afternoon, please welcome Kai Liang Ong from Aegis Packaging, whose mission is to make sustainable packaging possible. The floor is yours.
Hi, my name is Kai Liang from Aegis Packaging, and we're here to make sustainable packaging viable. Packaging contributes to 50% of all plastic waste, of which 90% are not recycled, 32% is leaked into our environment, polluting our oceans, just like the Great Pacific Garbage Patch, which is 3 times the size of France. And it's not just about waste pollution. 1 kg of plastic translates to 5 kg of carbon emission, adding up to 700 million tons of carbon emission annually. It is estimated that we consume 5 grams of microplastics weekly, and the problem is only growing. By 2050, plastic production will increase 4 times, taking up to 20% of global oil consumption and 15% of carbon budget. We need to stop our plastic diet and start reducing waste now. Unfortunately, sustainable packaging is not yet viable, especially for flexible packaging. Many existing plastic packaging today are not even recyclable, just like your potato chips, nuts, and pet food. They contain different material layers, which is necessary to protect the content and keep them fresh, but complicates their ability for recycling. On the other hand, current sustainable packaging, like mono-material, compostable films, or paper, can't really replace multi-material packaging as it lacks the high barrier properties required. That is why most businesses, even with ESG goals, needs to revert to multi-material packaging for practical reasons. And that's where Aegis comes in. We can make high barrier, sustainable, flexible packaging a reality today. Introducing Aegis Superior Coating Solutions. We have superior oxygen barrier, improving shelf life by 30 to 50%, and a longer shelf life means less wastage and more earnings for businesses. We are compatible with a wide range of existing products, ranging from coffee, snacks, to home and personal care like detergent and body soaps. And lastly, our cost is low, so switching to our solution enables businesses to comply better with the environment while maintaining profitability. Currently, we can improve the oxygen barrier performance up to 5,000 times, while next closest competitor can only achieve 1,000. We can do this because of our patented silicate polymer composite technology. What's novel is the process and formulation of chemicals, which is hard to replicate, and that's our secret sauce. Utilizing our core technology, we have a range of products in our pipeline to tackle this huge waste problem in 3 phases. We have successfully completed our first phase with our high oxygen barrier coating O2X, which is commercially ready. This alone can help with the recycling economy, as recycled plastics can save up to 30% of plastic packaging carbon emission. We are currently at the midpoint of the second phase, where we want to go beyond oxygen into water vapor barrier, as it is also one of our customers' key consideration. Improving substrate application means that we can cater to an even wider range of coating needs and capture a larger share of packaging market. And by the third phase, we want to move towards 100% compostable packaging. It means that even if the packaging is contaminated, it can still be fully composted. And with your funding, we are confident to say that as early as 2024, we can reach phase 3. Even with our first phase product, we are already ahead of our competition. When we look at our closest competitor, not only do we have superior oxygen barrier performance, but we are also affordable, even though we are just producing at a smaller scale. On the other hand, we realize that some of the more sustainable coatings are simply not as versatile for commercial adoption. Aegis is the only one that's able to excel in all 4 areas, and that's why we have such strong interest from the industry. We believe our timing is right. In 4 years, 13 leading brands has committed towards 100% recyclable, reusable, or compostable packaging, and we are currently in talks with 4 of these companies and in product trials with 2. And since we are selling coatings, we are very versatile. We can work with the entire value chain from resin producers like Dow, ExxonMobil, all the way to potential end brand owners like Nestle and PepsiCo. We can sell our pre-existing coating or work closely with them to customize a tailored solution. Since our inception in 2018, we have collaborated with global resin supplier to produce a high barrier PE film, as well as established partnership with A-Star. Presently, we are in paid pilot trials with over 40 plus large brand owners and large international converters. Our manufacturing line can produce 250 tons per month of O2X, and we're looking to accelerate that rapidly in the next coming years. This year, we are filing 2 new IP to further deepen our barrier coating technology. We have also started our first commercial sales and engaged with 4 distributors globally. With this traction, over the next 10 years, we expect to reduce plastic waste by 18 million tons. That is 60% of entire ASEAN's annual plastic waste. Reduce 90 million tons of carbon emission, which is 2 times Singapore annual carbon emission, and ultimately help us to hit the following sustainable goals, ranging from climate action to zero hunger. And we know our impact will only be greater as demand for plastic increases. With phase 1 and 2, we will address the $11 billion high barrier market, which we plan to replace existing plastic packaging with our recyclable option. Once we get to phase 3, we plan to penetrate the $160 billion global flexible plastic packaging market with our 100% compostable packaging solution, targeting to achieve 5% of market share. As coatings is around 10% of packaging costs, we project to reach $800 million in sales revenue in the next 10 years. Our key advantage is that we can scale rapidly since we have a modular design, allowing us to set up factories globally in 9 to 12 months, reducing logistic costs and carbon footprint. We can also contract toll manufacturers to supply the growing demand if necessary. Our current pricing is already competitive, and we can further reduce our pricing by 20% after scaling up. Our profit margin is 60 to 80% depending on economics of scales and marketing strategy. And we have the right team of people to do this. With a wealth of business experience, deep technical knowledge, vast sales network, and expertise in manufacturing, we believe that we have the capability to elevate Aegis to the next phase. In 10 years' time, instead of the garbage patch, these are the clear waters we can return to. We know that packaging is here to stay, but we know that sustainable packaging can be viable too. Partner with Aegis, let's progress commercially and sustainably by doing good and doing well. Thank you very much.
Thank you very much, Aegis Packaging, for your presentation. I'd now like to invite Kai Liang and Dr. Hong Cheong Loy on stage to join us in person for the Q&A. I believe our judge, Mr. Lim, has some questions for you. Over to you, Mr. Lim.
Hi, Kai Liang and Dr. Ong. Good afternoon. Thank you for your very excellent presentation. Throughout the presentation, you talk of sustainable packaging. I just want to be sure. Currently, your O2X, is it biodegradable?
Currently, our O2X is not biodegradable.
Okay.
It's in the phase 1. Yeah.
Phase 1. And in phase 3, you are working towards making it compostable.
Yes, that's correct. Yeah. By making the coating itself biodegradable as well.
Yeah. And compostable or biodegradable?
Yes.
Compostable, yeah. And when you make comparison with the existing competitors in terms of affordability and versatility, I realize you are making comparison with petroleum-based products. Is that right? Your PVDC, PVOH, or PU?
Yes, that's correct. There's existing coating solutions.
Have you attempted to make any comparison with other products? Say, for example, in the market now, we are talking about PHA, polyhydroxyalkanone, that is, although not available in commercial scale at the moment, but they claim to be biodegradable and they claim to be able to come in at a much lower price point. Have you attempted any comparison with that?
That is the third phase that we are looking at, where the substrate or the packaging is going to be biodegradable, but our O2X will move to the next phase that it has to be compatible to the biodegradable product as well, so that it meets the whole flexible packaging to be biodegradable.
Okay. Yeah. So in terms of cost of production of your O2X phase 1 and even for phase 3, how do you compare with existing petroleum-based coating? Are you much lower than them? Are you able to produce them at the same price point? Or?
We are currently pricing our current O2X coating at a competitive pricing against the other competition in the market. What I can say is that currently we are co-marketing with a global resin producer, and at the price point which we all agreed on, we can still achieve a healthy profit margin.
Okay. So your O2X is silicate polymers.
Yes.
Right? What is your barrier of entry for other people to come aboard and do the same thing as you?
I think the key thing is basically the IP itself. We have been patented, and actually it's also the know-how and the process itself. We have actually worked with the mass production manufacturers, which only partner with us only.
Okay. And you say that you have about, 40 partners who are at various stage of collaboration with you, is it?
40 paid pilot trials.
Yes, paid pilot trials, yeah. And can you tell us a bit more about this? What does it entail? They give you a sum of money to produce sample for them, or?
Okay, so mainly the pilot trials involve us coating on their materials or sending over our coatings over to their factories. So these paid pilot trials ranges from brand owners to converters. So brand owners like maybe big companies like Nestle, PepsiCo, they would like to take our coating on the R&D team to coat on their samples and also try on various different substrates. So that's some of the details of the paid pilot trials that we conduct with all these brand owners. And also converters, they would like to trial on their own production line, so to ensure that this can be ready for scaling up and commercial viability.
So you mentioned that your O2X in this phase 1 is already commercially ready and it can be used. So what would you do with the $1 million if you win this challenge?
Right, so the use of funds right now is mainly for the phase 2 and 3, where we can move towards better coating to serve the market needs better. Because from what we understand based on the feedback that we've gotten over the past few years, there's a demand and need for it to be stronger in terms of the water barrier performance, as well as a compostable, fully compostable solution. There's a lot of interest and demand for coatings on paper and compostable packaging. So the use of funds will be mainly used for R&D, getting the right lab equipment, expanding our research team, and of course doing more research collaboration with A-Star, as well as co-develop with our industrial partners new solutions.
Well, the packaging business is a big business, a big market there, and I hope you capture a big slice of the market.
Thank you very much.
Thank you.
Okay, any other judges? We have 2 minutes. Anyone with a question for Aegis?
Yeah, I guess I just wanted to understand a little bit more how it's produced. Like, what is the material based on? It says silica, and yeah, how do you?
The technology is based on a silicate, which is actually natural, and actually combined with 2 polymeric materials to form a very thin coatings onto the plastic film itself. And the coating is only about 0.3 micron thickness.
And so this product can be recyclable at the moment. It's not
currently. What we have done is that we have sent it out third-party recyclability testing, and they came back. Actually, the result is about 95% recyclable. But bearing in mind the fact that because when you laminate 2 plastic together, there's always adhesive, all this stuff. That adhesive itself is actually about 2 grams per meter square. Ours is only 0.35. So the 5%, if you just look at the 5%, right, actually ours is very, very minimum to it. So actually, I would say that it's more than 95% recyclable at this point in time.
Thank you.
Thank you very much, Aegis Packaging. I think our time is up. So thank you, judges, for your questions, and I'll invite you back to your seats. Thank you. For our 5th finalist this afternoon, please welcome Andre Laurentiu, who's dialing in from France for Divi Gas, and he will be sharing with us their solution on hydrogen membranes used in carbon capture at refineries. Andre, over to you.
Hello, hi everybody. My name is Andre Laurentiu, and I'm here to present Divi Gas. So we're going to talk about the hydrogen membranes used in carbon capture at refineries. Now, there's already 75 million tons of hydrogen being generated every day in the world, and it actually creates 2.5% of the world's emission, more than the United Kingdom or Indonesia. Now, you could actually make this process clean, even while using fossil fuel to make hydrogen, if you capture the CO2 and turn it into blue hydrogen. Very often, when we're talking about future hydrogen projects, however, we're talking about green hydrogen, which is where you don't use any fossil fuel in the process and you just make it from water. However, green hydrogen is likely going to take a while. To kind of put this into perspective, the International Energy Agency thinks that by 2050, this is this graph here, you'll have a mix of green hydrogen and blue hydrogen essentially making up our energy composition. But we need to switch everything that we're doing today, which is overwhelming gray, into carbon captured hydrogen, where the CO2 is stored underground or underriver and things like that. And this is what we're talking about today. So to capture the CO2 in a hydrogen plant and a hydrogen system, which you find at refineries, you need to separate it, compress it, transport it, and then store it and monitor it. You would think that these first 2 steps would be a more minor part of it, since they're kind of doing it already today, but overwhelmingly, separation compression is actually 50–75% of the entire cost. And there's several studies that give the breakdown of those economics. Now, this is where we come in. We are a hydrogen separation technology. It is a membrane, which is a mechanical filter, just like you would have essentially an AC filter. It works at the nanomolecular level, where you have gases around the fiber and only the hydrogen makes it to the center, very pure. What we bring to the table, what is new about this technology, is the excellent performance in separating hydrogen from CO2, which is one of the hardest gas to separate out there. Now, we've taken several studies, and they each have their price of how much it costs to actually capture a ton of CO2 in a hydrogen stream, the International Energy Agency, IPCC, and et cetera. But if we take the cheapest one, the one at $51 here, and we break it down, if you compare it with us, you can see that we actually save most of the money on the compression. We don't change anything about storage and transport because we don't have anything to do with that. But because we can retain the pressure of that CO2, we can dramatically reduce the price of carbon capture at those hydrogen plants. So today they use amine washing units. These are these gigantic towers which use toxic chemicals, have a lot of moving parts. It's very sort of complicated and OPEX heavy, but it's got good economics, CapEx heavy. Membranes, on the flip side, could keep the CO2 pressure, have much more lower upfront cost, no operator, much easier, just these banks set up, and then that's it, it just works. Now, Singapore specifically would actually reduce its emission by 10% if it captured the hydrogen from those plants today. Singapore has 3 refineries, but they're very large. The average refinery is 100,000 barrels a day, versus in Singapore, all 3 of them together represent 1,800. So it's an average of 18 times the average refinery. So you can, in another word, you can imagine there's 18 refineries in Singapore, but it's under 3 companies. So 10% of the emissions of the country could be reduced by switching to carbon captured hydrogen. Now, we already have plenty of clients where we don't struggle in finding people interested in this. We have 2 carbon capture projects that are currently being looked at by clients, and we're going to send them pilots very soon in the Netherlands and in Italy. And I'm sure we're going to be finding much, much more. And we have other clients in other use cases as well for this product, but nothing yet in Singapore. So, you know, it's very simple for us. We just make the banks of tubes. We put the fiber in it. We make sure that it works. And then we send out to the clients, who then takes care, the clients being not the refineries themselves, but their technology provider. And then they take care of setting up the piping and the other associated minutia, just compressors and classic stuff that goes around it. But overwhelmingly, the center of the system is this technology. The cartridges inside last for about 2 years and they get replaced, but the entire system is certified for 10 to 20 years. Now, this technology was the invention of my co-founder, Dr. Ali Naderi, that came out of NUS here in Singapore, and he's made other membranes and other polymers for the space industry, for re-entry heat shielding for the space shuttle, as well as car dampening mechanics polymers. And he has done this before, and he's now doing it independently. He's made stuff for BASF with NUS, but this is our technology. There's no NUS or BASF involved. Now, I'm a repeat entrepreneur. I've led a company in Series B before, 4% 30 and 30, and it was in the software space in the United States. And now we have raised several millions from these people that you have here, Men and Homo, who have a lot of expertise in this. We haven't fully announced this yet, so this is the sneak peek, and we'll announce the full amount very shortly. All right. We also have amazing local and international advisors that have previously built and scaled very similar products and are helping us in getting this across the line. On top of that, we are currently drafting the patents for the IP, so we will completely own the international portfolio. And we've already talked to NUS, make sure there's no overlap with Ali's research or mandate, and we've got this in written form, so we're completely covered in that sense. Now, for the Liveability Challenge, we've sent out messages to Exxon, Shell, and the Singapore Refining Company, but overwhelmingly the process is going to take longer than we could for this challenge. That being said, we're working on it still. And if we were to receive the funds from the Liveability Challenge, what would happen is that we would go to them saying like, hey, we have this allocation by Temasek to actually make to switch your plants to carbon capture, and this, we are convinced that this would help them move on to actually being a first mover instead of a follower of Europe. It would help them become a first mover and switch to carbon capture, probably on a small setup in 2022, and then on a full scale in 2023. And that's it. That's DiviGas. And you can help reduce 10% of Singapore's emission today.
Thank you so much, Andre, for your presentation. And joining us here in Singapore is Dr. Ali, his co-founder of Divi Gas, and he will be taking the stage to answer questions. Okay, guys, I believe Alice has joined us here as well, and you can see her there in front of you as out at the side. Hi, Alice. Thank you so much for joining us. Over to you for the first questions for them.
First of all, thank you, Andre, for a wonderful presentation and indeed for your submission. First of all, can you explain to me exactly how this technology would make cities more sustainable and livable?
Well, I mean, a significant portion of cities' emission is industrial emission, and overwhelmingly there's an underlying existing infrastructure in that is using already hydrogen as a feedstock or as a reactant gas in a large variety of use cases that emits a very large amount of CO2. So tackling a critical piece of this infrastructure by using better carbon capture around the manufacturing of this hydrogen would just make cities significantly more livable.
Thank you very much for that. So, you know, we are in the year of COP26 happening in November. And what we are seeing is that cities and countries around the world are committing to be net zero carbon, some by 2025, but most by 2050. And of course, what they are focusing on is on decarbonising their buildings, so creating ultra efficient buildings, decarbonising their mobility systems and their energy systems. And can I ask you, does that in fact enhance your business model, or does that jeopardise your business model?
Neither. It just gradually evolves and changes it. You know, we're for the next 20 to 30 years, we're going to be focused on, you know, industrial hydrogen and sort of like these use cases. As I mentioned at the beginning of my presentation, you know, the International Energy Agency predicts that not only will hydrogen use case all across cities and industrial sites will go from about almost 100 million tons today to 500 million tons, so 5 times over the next, you know, 30 years. But half of it will still be made from fossil fuels and this needing technology like ours, and half of it will be made from green hydrogen, water, and that only emits oxygen. Now, today we don't have a product that tackles this green portion, but that still means that our market is going to 2.5x in the next 30 years. And become much more critical piece of the infrastructure of our everyday lives. But this is also our first product. So we're a gas separation technology, and we absolutely plan on also helping in building oxygen separation, which is useful in the green hydrogen space and in a slew of other use cases. And we have 30 years to figure that out.
Can you just tell us a little bit more about how the technology works specifically? As well as telling us a little bit about its application.
Yeah, I'll let Ali explain the technology and
technology. Technology is like membrane technology, polymeric membrane technology, which like is a filter. Membrane is a filter, and for gas separation is an angstrom level. So we molecular design the selective layer of a hollow fiber membrane, and let the gas passing through and permeate and purify the hydrogen and capture the CO2 in the retentant. And not only we develop this membrane very resistant, chemical resistant, and can tolerate high temperature and high pressure all together at the same time, but we made it more economical by making a dual fiber. So this technology is a kind of like the very robust membrane and more, very economical membrane. Yeah.
So in terms of use cases, you know, there's already several billions of dollars worth of membrane sales that are available to us in existing refineries just for improving their efficiency, because the average refinery tends to waste about $6 million of hydrogen in just raw output. But as I mentioned, you know, we're going to be all over carbon capture for hydrogen plants. Even there's niche use cases, everything from methanol production to nylon sticks, which is the dashboard of your car, uses hydrogen to be manufactured. And they all need this critical piece of infrastructure because they all struggle with separating hydrogen and using the hydrogen they use today more efficiently. It's not well known, but it's actually a massive, massive existing petrochemical industry.
Thank you for that. And can you tell me, just in terms of the development of the product, what stage you're at? You mentioned 8 pilots, that you have a plethora of clients lining up. Can you tell us a little bit more about those agreements, and if you've actually had any projects that have moved beyond the pilot stage? So where are you at versus commercialization?
So we have one of our clients that came to our facility in Singapore that actually tested a battery of tests in person. That client was very knowledgeable because of his past history with working with membrane. He knew exactly what to look for. We passed those tests with flying colors. We submitted our product to extreme acids for extended period of times and continuously tested it with him for several weeks, I believe, maybe a month. And we passed this with flying colors. Our client actually extended their LOI with us afterwards. Otherwise, we actually have 8 clients total that are, and we could have more, but this kind of became pointless. We just have a battery of clients that are all waiting for us to send them our pilots, so sort of like full-scale modules, to be able for them to try it first in their lab, then on site. They're waiting on this. So we closed this round that I just mentioned that we're going to be announcing in a couple of weeks, the full amount and all the partners, et cetera, to actually, by the end of the year or early next year, be able to have on-site full-scale pilots at facilities, sort of like fully commercialized products. So they're waiting on us. They're sold and convinced by the performance that we've shown them and promised them, and et cetera. There's varying degrees of testing there. But basically, by early next year, we'll be on the ground, proven, commercialized, and scaling up for much larger mass market adoption.
Can you tell us about your growth plans over the next couple of years? Because obviously, any of these solutions, we need them to get to scale very, very quickly if they're going to change the planetary situation.
Yeah, so that's, I mean, you know, what makes me sweat is this. It's like, I mean, it's a couple chess moves away on the board, but, you know, I look at the Tesla manufacturing challenges that they had when they had an incredible demand and how much of a challenge that was for them. And I think we're headed for exactly the same thing. Now, they've overcome it, and I hope we can too. But honestly, once we have this product commercialized early next year, the demand that will come from afterwards, we've already talked to clients that have asked us, okay, we'll do commercialization with you early next year. For 5 modules, you know, a couple $100,000. But if it works, the year after that, can we do a $50 million deal with you if it works? I'm like, okay, can I produce $50 million worth of this for one client in 1 year? It's a massive challenge. But that's where Man & Hummel, which is our lead investor, one of our lead investors in this round, actually has massive capacity that we actually could quickly transform into a mass output facility. Now, we haven't decided if we're going to be doing that route, or it's going to depend on the local, you know, sort of like conditions and et cetera. But we will be very much sort of like depending on external partners to sort of like mass output this to a very large scale.
So partnership and collaboration is key to success. If we have time for one last question, I just want to ask you about your revenue generation model. If you just could tell us very quickly about that.
Very short. Thank you. Andre?
Sorry, I had a problem with the connection for half a second. I'll let Ali answer.
I was asking about your revenue generation model.
Oh, sorry. Okay, I got it. Yeah, so very simple today. It's equipment sales. You send, you know, modules out on the block with a cartridge to replace it every other year. Right now, it's very simple. We do think we want to upgrade in the future with a fancier revenue model, a per hydrogen separated value, and et cetera. Today, it's very simple. Sell a unit in a system and replenish the filters on a multi-year basis.
Thank you very much. Thanks so much for your questions, Alice. And thank you, DiviGas, Andre, and Ali for joining us. Now, last but not least, our final team this afternoon. Please welcome Brian Oh from New Battery Materials, who will be presenting to us how the company will produce clean and sustainable lithium.
In the last 13 years, I've accumulated many smartphones starting with my iPhone 3. All these smartphones are powered by a lithium-ion battery. There are still valuable raw materials inside all these lithium batteries, including this iPhone 3. Instead of making new batteries for the world, what if there was a way to convert old lithium batteries into new ones? My name is Brian and I'm the founder of New Battery Materials, and we're here to produce clean and sustainable lithium. We use lithium in our everyday lives. The most common application of lithium is lithium batteries. These are found in our electronics, energy storage, and more increasingly, our electric vehicles. EVs play an important part in meeting our global goals on climate change. By 2030, we'll see over 100 million electric cars on the road, growing at 33% year on year. However, by 2023, there will not be enough lithium being mined to keep up with the demands of EVs. As such, our world will face a lithium shortage with over 800,000 tons in 2030. To attempt to meet this demand through mining, it will increase global CO2 pollution by 12 billion kg. Existing batteries can be recycled to supply lithium, but current recycling methods are only able to recycle a small percentage of lithium batteries globally. These existing methods are pyrometallurgy and hydrometallurgy. They involve the use of high heat and harsh acids to extract the valuable raw materials. These methods are highly costly and highly pollutive, and they're also unable to scale efficiently to meet the incoming demands of lithium batteries. Our new solution is a game changer, being the world's first patented electrochemical battery recycling technology. Our foundational patent is in 7 jurisdictions covering all major markets. With our modular system, we're able to scale rapidly. Our system is able to double the processing capabilities by using only 10% extra space, without the need to overhaul the entire plant. This makes our system 10 times more scalable. Using our proprietary reusable chemicals, our technology is able to continuously operate without the need to add more chemicals. This allows us to have 10 times cheaper operating expenses. At the same time, this results in a near zero waste process. Due to the nature of our process, our main consumable is electricity. This brings down our carbon emission by 100 times. Using our proprietary solution, lithium in batteries are targeted and extracted out. A small voltage is passed through our system, allowing lithium ions to move across our membrane. These ions react with water to form aqueous lithium hydroxide. This can then be dried to form 99.9% pure and solid battery-grade material. There is a huge market for recycling these lithium batteries. The potential for recycling is a $100 billion industry, with China being the leading market due to its high EV uptake rate. 54% of China's EV batteries are lithium iron phosphate, LFP for short, and the world is shifting towards LFP due to its lower cost and higher thermal stability. We are currently the only technology in the world that is capable of recycling LFP batteries profitably and in an environmentally friendly manner. As such, there is an untapped market potential of over $12 billion, and this will be our key target market. We will begin our launch market in Singapore as a pilot site to showcase our technology on a commercial scale. We are able to close the lithium loop, creating a circular economy. Currently, the majority of lithium is sourced from mines, which are used in EVs and energy storage. At the end of the life cycle, these batteries are crushed and sent to us for recycling. Our system will reduce the dependency on these mines by producing clean lithium. In addition, rejected batteries in the manufacturing line can also be immediately recycled. We run a build, own, operate model whereby crushed used batteries enter our recycling process. We then process these crushed batteries and recover the valuable battery materials inside. With LFP as our starting market, we recover battery-grade materials which can then be sold on the commodities market. We have gained tremendous traction in the industry, with 2 pilot site offers from listed recyclers, one of them being EnviroHub. They will each be able to supply enough feedstocks for our pilot site plans. EnviroHub will also purchase all our pilot site products, and we are in the process of listing our product on the Technologies Metal Market platform. For R&D, we're supported by NUS and Temasek Poly on technology development, and we're currently in talks with additional collaborators, regulators, and investors. We have a huge impact on reducing pollution in our world. By 2030, we will supply 10% of the global lithium shortage. This allows us to offset the demands from lithium mines. As such, we reduce the amount of CO2 emission equivalent to 260,000 cars on the road. We save 23 times the daily water consumption of the entire Singapore and land space the size of nearly 24,000 football fields. Our plan for the next year is to construct our pilot site in Singapore. We're looking to fund our pilot site through the Liveability Challenge for $1 million. This allows us to increase our processing capabilities by 250 times, proving a proof of value on a commercial scale. In order to achieve this, we'll invest $300,000 in R&D to upscale our technology. We'll then use $200,000 to construct all the necessary systems for our pilot site. The remaining funding will be used to validate our technology on an operational level. We've already secured $200,000 of funding to develop our technology further. We're currently in talks with potential collaborators in China, and our plan is to set up facilities beside battery crushers. We will then expand our market coverage and capture the NMC battery industry. With our highly modular system, we expect our revenue to reach over $200 million by year 5. By our second year, we'll scale to a size whereby we will be cash flow positive. We have a powerful team here today with startup, engineering, and technical experiences to ensure the success of our company. Our team is completed with vast industry and investor networks in Singapore and China. We plan to make our technology the mainstay of battery recycling. As mentioned by the co-inventor of lithium batteries, Professor Akira, recycling batteries is the key to securing enough raw materials to power the surge in electric vehicle demand. And I hope that someday, the lithium in my iPhone 3 will contribute to powering my future electric car. Lithium is the key to our clean future, and we hold the key to clean lithium. Thank you.
Thank you very much, New Battery Materials, for that presentation. Round of applause for them. We'll now move into Q&A, and now I'd like to invite both Brian O and Kenneth Palmer from New Battery Materials to join us here in person. And John, I'd like to invite you to start us off with the questions.
Thank you, Brian, Kenneth. Yeah, very, very compelling, and it's a problem we're all familiar with. We all have iPhones and lots of lithium in our households. So you mentioned a couple pilot partners and that they have sort of ready lithium for you to process. A big part of this obviously is sort of logistics, right? How do you get to the lithium that needs to get recycled? So could you just tell me a little bit more about how the logistics work for them, and also how many players like them are there around the world? Can you scale, and how big is that opportunity if you're just going to these partners?
Thanks, John. That's a great question. So what happens is that we try to partner with battery crushing companies, something like what we have in our partners here. And what they do is they take the spent battery and they crush it into their end product, which is called black mass. So the black mass at this point, for LFP batteries specifically, is considered waste to them, and they actually do need to find a way to dispose of this waste. So what we do is we actually take the black mass, we process it, and we actually generate battery-grade lithium hydroxide out. So this can actually be sold off to battery manufacturers, and this allows us to close the loop here.
Do you have any sense of the scale? I know you said it's 54%, I believe, of the overall battery market.
So the interesting thing is that lithium iron phosphate, LFP for short, is growing globally, more specifically in China. Companies like Tesla, NIO, XPeng, they're all using LFP batteries in their cars, generally because it's cheaper to manufacture and it allows them to bring down the cost of the electric vehicle.
Okay, and so batteries that are in our phones, are they LFP batteries as well?
Sorry, didn't catch your question?
The batteries that are in consumer electronic devices, are they LFP?
So in consumer electronics, it's slightly different. There are different types of battery chemistry inside, but nonetheless, they're lithium batteries. Our technology is able to actually recycle them in the future, but the battery chemistry that we're targeting right now is actually the LFP battery.
Got it. So the first beachhead is the LFP battery.
You're right.
Which is currently used for EVs.
Yes, correct.
Permanently. Okay, understand. Thank you. So can you just tell me a little bit about costs? I understand hydrometallurgy is expensive. Give me just a sense of your cost breakdown.
Right. So the interesting thing about cost for hydrometallurgy and pyrometallurgy is that it's actually very expensive and pollutive. The hydrometallurgy process, what they do is they take acids, things like hydrochloric acid, and they leach out the battery and the raw materials out of that. At the end of that process, the acid actually needs to be disposed. unlike ours. So our solution is actually a regenerative solution, meaning that when you put in the black mass and the feedstock, at the end of the process, the chemicals regenerate and there is no waste process at the end.
Got it. So just kind of going back to the other types of batteries, you also, I think, mentioned in the presentation a bit about solar panels and solid-state batteries. So how much adaptation needs to take place in the process for you to go to other types of batteries as well as these types of products?
Actually, the interesting thing about solar panels and even things like your energy storage, your UPS, they all require lithium batteries. In the future, your 5G base stations also require lithium batteries as a form of energy storage. And these energy storage do use LFP predominantly. And these LFP batteries will also become our feedstock. And they are definitely a market for us.
Right. Okay. I saw a lot of figures on sort of water saved, number of cars taken off the road. I guess for us as judges, we're trying to kind of get a sense of relative impact of all the different projects. And the just very obvious objective measure is carbon, right? But I don't think I saw a number for carbon. Do you have a sense of that?
Yep, so actually the carbon is the car number that we're talking about. Yeah. The number of carbon dioxide polluted from lithium mining itself is very high. I've mentioned in my pitch, it's about $12 billion kg worth of carbon dioxide emission. So when you use our process...
Sorry, that's annually?
Sorry?
That's annually, is that right? Every year?
Right.
12 billion kg every
year? 12 billion kg.
Per year.
Yeah. And the thing about that is that with our process, right, we're actually able to offset the carbon dioxide pollution from a lithium mine. And that comes in the cost savings, which we've highlighted, to over 260,000 cars on the road being driven for 1 year.
Got it. Okay, I guess last question from me. It sounds like a pretty technical process. You have a couple patents and so forth. Is the team, I mean, do you have everything you need? Is there anything that you need to supplement, any bottlenecks or holes to plug in the team to move that forward and just make sure that you are able to scale this?
Sure, maybe I'll let my partner Kenneth handle this.
Yeah, so I think for us to really get from here to like a pilot scale, which is really where the development can really accelerate, what we require is real mechanical engineers, which we have on the team. We're well equipped with the skills and knowledge. And not only that, we have the inventor on our team as well, and we're backed with a whole network, and we're strongly supported by them through seasoned advisors, mentors, and through all these guidance that we have from them, we're actually ready to really bring it forward. Because the good thing about our technology is that we are also trying to adapt on current, mature and existing infrastructure that has already been built and used in many industries. So what we're really trying to do is we have laid this plan for ourselves to really accelerate the tech. And now it's really just to try and work at it and really bring it to where we want to go. Yeah.
So it's less on the R&D, it's more on the scaling.
Yes, a lot on scaling.
Got it. Actually, one last question, if I may. So it sounds like China is a big part of your story. And there are always questions about IP and protection in China and so forth. Like, how do you guys think about that risk?
All right, so I'll take the question. We agree with you. The good thing is that our model here, our business model, is to actually be a build, own, operate model. So we will set up our plant beside battery crushers. In this case, this will allow us to protect our technology. But what I'd like to highlight is that it's not something that's easily copyable. We have a lot of trade secrets inside the system and a lot of equipments, extra equipments that we put inside that is not visually seen in that process.
And maybe I can just add, I think when we really want to protect our IP, it's always about trying to develop faster than your competitors or whoever would try and copy your product. And as we speak, we're actually also trying to explore and speed up this development, but also research onto other battery chemistry so that we can capture a wider range of the market. Yep.
I think, Steve, you have one last question for this team?
Just ask the question I was going to ask. But the one question I had for you was a little bit around, it looks like you've had $200,000 investment to date. Is that correct?
Yes, we have $200 from NUS to do research and development for our different types of batteries.
Okay, and the plan is to build and operate yourselves, to basically do the production yourself?
Correct.
Okay, to get to that point, you talked about 2 years cash flow positive?
Yes, by year 2, we'll scale to a point where we'll be cash flow positive.
And so to get to that stage, how much money will you require?
We're looking at an investment for CapEx about $1 to $2 million.
Okay, thank you.
All right, thank you so much, New
Thank
Battery
you.
Materials, and thank you, judges. That's all the time we have. Thank you. Please give a round of applause to all our finalist teams for their wonderful presentations and for tackling all the difficult questions from our judges. Thank you so much, teams, for all your hard work and insightful pitches. We'd now like to invite the judges to our VIP room to take a recess so that you can deliberate. For our guests, please stay with us as we move into our next segment, where we will hear from last year's winner and also an exciting plenary discussion, the intersection of sustainability and innovation. This will be moderated by the Eco-Business Partnerships Director, Megan C. For now, don't forget to vote in our audience poll as we will be closing this shortly. The QR code can be located on the right and left of the stage for our in-person guests and also online for those who are joining us virtually. There will be one lucky participant who will win a gift package for guessing the winning team, so best of luck. At this point, I'd like to introduce our next guest, the winner of TLC 2020 Turtle Tree Labs. The biotech company won funding of $1 million last year for their cell-based technology to produce human milk from cells, and has gone on to raise $6.2 million in pre-Series A funding. So what has their journey been like and what lies ahead? We'll now hear from co-founder Feng Ru Lin.
Hi everyone, my name is Feng Ru. I am the CEO and co-founder of Turtle Tree. First of all, thank you so much for this opportunity to speak at this grand finale of the Temasek Liveability Challenge. It has been a great honor last year, quite a shock as well for us to have won. It was such a humbling experience to be on the challenge with a great number of different startups worldwide, especially in Singapore as well. And we learned a lot from the judges. We learned a lot from our fellow competitors. And I hope to be able to share some of the progress that we've made as Turtle Tree over the past 1 year. We are a biotech company based primarily out of Singapore, and we just set up our global R&D HQ here in California. And we are the first company to pioneer the technology to produce milk from all mammals using cell-based methods. A bit about the background of the company. When we first started, I actually had a hobby to make cheese, and it was quite a fanatic period of time. I went up to Vermont to learn how to make cheese for a few weeks, and I wanted to replicate this whole process back in Asia. In Singapore, obviously, there were no cows, little access to fresh raw milk, so I had to go down to Indonesia, to Thailand, trying to look for sources of milk. But even in those places, there were challenges around contract farming, around hormones and antibiotics that are being pumped into the cows. And as a result, the milk quality suffers, and I couldn't make the high quality cheeses as I was used to in Vermont. So back then, that was about 4 years ago, I was still working for Google. I come from a tech background. And in my office in Singapore, that was when I met my co-founder, Max. He was on stage sharing about different transformative technologies, ranging from companies like Memphis Meats to Blue Nalu, who are using cells to create meat and seafood without having to go through the animal. So back then, that was really intriguing for me. We started chatting about using similar methods to make milk. Nobody else was doing it back then. There were some companies that were producing single proteins or single complex sugars found in human milk, but nobody was really producing the full composition of milk, all 2,000 ingredients in a single process. So we started to explore the cell-based methods. So in 2019, we made some breakthroughs together with our scientists and filed our patents. Fast forward to today, we have about 33 employees and growing quite rapidly. Beyond just what milk does, what we're able to produce with our technology are other enabling technologies for the cell X space. For example, to grow the cells, to produce the milk, we needed these growth factors that are also very important, very crucial for the cell-based meat industry. So we have been able to commercialize and work with some cell-based meat companies to enable their growth, to drive the cost down to something that is food viable. So back to Turtle Tree, how we've progressed till today, really we now are a platform that can enable sustainable food production. It could be milk products, it could be cell-based meat products, and so on. So if you guys recognize the Turtle Tree logo, it looks like of course, the Turtle Tree shell, but also the cross-section of a tree or a thumbprint. So really symbolizes man's print on nature. In the future, our dream in Turtle Tree is to have our brand as a household brand. So it allows consumers to recognize this Turtle Tree logo, and it could be in the form of an ingredient in the product. It could be in the form of engineering technology that is involved in the process of producing the food. But having a Turtle Tree inside product means it's better for the environment, better for the animals, and better for the individual's health. And that is what we want to allow consumers to have the choice to make. So diving into what we are going to do in Singapore, our plans here, as we all know, Singapore has a massive food security challenge. We set up this goal for us to produce 30% of the country's nutritional needs within the country by the year 2030. And this is a very long stretch. Today, we are at less than or around 5%. So there's still a ways to go before we can get to that point. To support that goal, the government agencies are really behind all of us food tech businesses and startups. We've got Singapore Food Agency, we've got Enterprise Singapore, Economic Development Board, to bring lots of global partnerships, a lot of local partnerships, regulatory support to help all of us succeed. And as a result, of course, Just Asia is the first company in the world to be able to launch cell-based chicken in Singapore. And we do expect other cell-based food, be it meat or milk companies and technologies, to follow as well. So in Singapore, our plans are really to set up some production capabilities within the country over the next 12 months. And this includes some pilot production as well as application development with a lot of CPG brands for Asia. To give you guys some fun facts, a lot of people might not know, but 4 out of the 5 biggest infant nutrition companies have production in Singapore, and they also have a lot of R&D that is being done in Singapore. So we are working with a lot of these infant nutrition companies to build POCs, to do a lot of product development, to see how we can introduce some of these high value, high functional blends for the infant nutrition industry, as well as for the functional food targeted at adult nutrition, performance nutrition, and senior care. In this whole journey, Max and I, we learned a lot. We have a lot of very strong scientists, very strong and seasoned biotechnologists surrounding us, from mentors to advisors to our own team. And this is how we've been able to grow the company. We've been able to activate the right resources, as well as reach out to the right folks as partners to accelerate our progress. And that's why we managed to get to where we are today, 3.5 years down the road. So far, we have been very thankful for the team at Temasek Foundation and the Liveability Challenge, because that global stage really allowed us to put ourselves out there, share our mission, and highlight the need for food security. After we've won or took part in that contest, we've had so many partners, so many collaborators and investors who reached out wanting to connect with us or help us connect with folks that they think it's relevant for our business. And where we are today, we are going to launch some of our first products onto the market sometime next year. Our first ingredient is really a blend of certain complex sugars, these HMOs, that are found in human milk. So there are a few companies out there who've been able to produce a handful of these HMOs. For Turtle Tree, because we're using cells, we're using mammalian cells to produce these HMOs, we have the deepest portfolio in the whole industry. So for our first product, we have a blend of 2 or 3 of these HMOs together with lactoferrin, which is a protein found in milk, to build a better for you blend that can be included in your regular cup of yogurt or your regular bottle of kombucha or even a performance food product, which we are working with some of our partners on. So if we highlight the importance of lactoferrin, lactoferrin has a lot of antimicrobial benefits. It has a lot of benefits for the gut as well as mental acuity. And this lactoferrin product is not necessarily new to the market. Currently, there are a few companies producing it as a supplement for iron-binding properties. It is also included in some infant nutrition products. But if you look at how lactoferrin is produced today, it is actually really harmful. It's a very energy-intensive process. There is very small amount of lactoferrin within the full milk. So when dairy processors try to pull the lactoferrin out of the whey, that's a byproduct of cheese making, there is still a lot of the other whey product that it's very hard to sell to without the lactoferrin inside. So there is a lot of waste of whey as a byproduct when you pull out lactoferrin. As a result, the market needs a lot more lactoferrin and there's not enough. The price point for lactoferrin is very high, which is why for Turtle Tree it makes sense to target some of these high-value ingredients in our early days. And as we are able to scale up production and scale down cost, we will be able to reach price points for some of the cheaper or the lower value milk proteins or milk components that are found in milk. So back to where we are, we will be launching some of our first B2B and B2C products next year, as we have been working with quite a lot of global partners from the CPG food industry, from dairy companies, even food industries. We're very excited to bring some of this better for you, better for the environment, and better for the animal food products sometime next year. Thank you.
Thank you, Fengru, for the amazing presentation from Turtle Tree Labs. I am Megan C., Director of Partnerships for EcoBusiness, and I'm very pleased today to be moderating today's plenary discussion, the intersection of sustainability and innovation, how do we achieve impact at scale? For those of you tuning in from wherever you are, thank you very much for joining us for today's Deliveability Challenge Grand Finale. We do have a Q&A session after this, so for the audience in the room, please scan the QR codes that will be up on the projector screens in a little bit. And for our virtual audience, please do input your questions into the respective chat boxes. Allow me a few moments just to set up the context of our discussion today. Sustainable innovation, that is, creating new products and sustainable solutions that contribute to human development while protecting the world's natural resources, has never been more important. The impacts of the COVID-19 pandemic have caused unprecedented challenges worldwide, characterized by shifts in the market sentiment, government regulations, technological changes, and also consumer preferences. These shifts have created a sense of urgency for businesses to improve their sustainability credentials, forcing a reassessment of business models and approach to innovation. Many industries, from energy to food production, to finance, to transportation, have been disrupted by the sustainability trends. At the same time, a recent IBM study showed sustainability is important to nearly 8 out of 10 consumers, and of these, over 70% will pay a premium for sustainable brands. In these unique times that we live in, it is important to recognize that businesses and governments should make room for innovation in the way that we work and live to deliver superior post-pandemic growth and performance. Amongst others, the development of new business models along with the changing consumer mindset relative to sustainability will be important drivers towards a sustainable future. With that, the questions we seek to answer today run along the following lines. How are organizations today responding to evolving consumer choices and increasing stakeholder demands? And what are the drivers and barriers to organizations investing in sustainable innovations? And with this, I'm excited to introduce our panelists for today. We have Mr. James Tan, the managing partner of Quest Ventures, a top venture capital fund in Asia. And we have Ms. Lorena Paglia, the lead for Microsoft's Asia Sustainability Chapter. James and Lorena, thank you so much for joining us today in this discussion. Please feel free to chime in as well on each other's statement as we go along this discussion. I'm going to pose the question to James first. In your experience wearing various hats, many venture-released organizations, what do investors look for today when they look at investing in companies that have impact other than financial performance?
First of all, thank you very much. Hello, hi. No. Hello, testing.
Okay, you're good.
Yeah, very good afternoon, everyone. Congratulations to EcoBusiness for putting together yet another year of a very successful TLC. Thank you to Jessica, Chiam, and team for putting this together. I think Megan has really painted a very good macro landscape of what's happening around the world with respect to what is happening in the investment or environmental landscape. Want to just bring it down to just the investment side, which I know we can dive into in the next 30 minutes or so. For investment itself, broadly speaking, investors fall into three buckets. First one will be alignment. It is a very basic level where we try to align our portfolio with some ESG factors and try to make it perform according to those ESG requirements. The next one will be integration. Integration will be really taking a very active approach to portfolio strategy to make sure that the investments really deliver not just alpha, but also deliver ESG factors, just comply with ESG factors. The third one, which is the most in-depth, will be impact. It really takes a very active approach in making sure that investments as a whole have all the ESG components in place, can deliver sustained alpha in sustainability. So as a whole, we are seeing that more and more investors, 80%, are moving from passive investment, that's the first one, towards more active involvement in the portfolio. And that, to me, is a good sign. Because as a whole, ESG focus or ESG aligned portfolio have outperformed broader market indexes in the last few years. So it's a good sign for me. It's a good sign for the broader investment landscape. Definitely a good sign for the sustainability sector that we're all in.
Yeah, and just following up on that, I guess, how do investors then differentiate companies that have the potential to scale for impact versus those that may not?
How do we look at companies that have the potential to scale? I think this will be the same as we'll look at companies like today that we have seen in the Liveability Challenge, where we look at not just the size of the market that they're trying to tackle, the meaningfulness of the problem statement that they're trying to solve, and the team itself. And then, of course, we put in all the ESG factors that we need to check off and making sure that those really have measurable, impactful, meaningful outcomes.
Okay, thank you for those insights. Lauren, I'm going to just go on to you as well because you're from Microsoft. Everyone here knows Microsoft, and it's launching actually the second cohort of its Microsoft for Sustainability Innovation Program, which leverages its resources and ecosystem to help corporates collaborate and transact with the most innovative sustainable solutions around. With this, I'm also very excited to announce that Microsoft will be coming on as the TLC partner for the following editions in providing an ecosystem for software solutions to grow to commercial viability as well. So Lorena, please tell us more about this program and your involvement in our TLC program and so for the coming years.
Thanks very much. So really excited to be part of this program. And first and foremost, before I jump into that, I just really want to touch on the incredible and impressive finalists that we had today. The science, the passion, and also the technology and the thinking behind what they had to bring forward to us. And that's also in the spirit of what the TLC program and the Sustainability Startups for Innovation program is all about. Our program in particular is about creating that environment and that ecosystem for our startups to be able to come through, to be matched with the right mentors. As you saw today as well, the incredible technology that had to go into this space and the thinking so they get matched with the right stakeholders or the right SMEs, within the Microsoft business as well. But then also connected and matched with the right partners and companies through the ecosystems. So we're really excited to be able to bring that in the following years with TLC program going forward.
That's great to hear, and we're very excited to have Microsoft come on board as well. Just a question to James as well then. In terms of success stories that you've seen in the region, where have companies managed to combine both sustainability and innovation to achieve impact at scale?
I think success can be measured not just at the startup level, but national level. I think it is testament to all the efforts from not just eco-business, but the entire industry for having pushed, driven, advocate, and so on. And now the government actually has a plan, has a green plan, national green plan to get there. Of course, this is only at the Singapore level, but we're also seeing other countries like Korea and so on having their new development plan, taking into account environmental factors. And that has cascaded downwards to more support for startups. And some of them who have right on this national agendas, 30 by 30 for our food sustainability and so on, includes the likes of Alchemy Food Tech, which has raised from Thai Union Group, includes the likes of Unicorn, which has raised money to go into, to do better IoT for aquaculture, and so on. So there's been meaningful success for startups.
And thank you for that. For Lorena as well, I guess from Microsoft or your experience as well, tell me some success stories you've seen around the region.
You know, there are so many shining lights in terms of success stories within the region, and one particular that comes to mind is Jejak, which is in Indonesia. And this particular startup, they provide carbon offsetting by planting trees, and they've partnered with Gojek in Indonesia. This particular is an example that came through the startup program as well. And what they've done, it's a really fantastic example of how we use our startup program to be able to match with the right partnership and also get that right scale. So this is also some of the impact and what we need to be seeing across some of our success stories. They need to have, as we also saw today, the right kind of business model. They need to really put some thought into how they're going to go to market, also the kind of partners they want to be partnering with, and also what is also going to help get the best scale out of these situations. So there's some of the great stories that I've seen coming out of the region.
No, for sure, and that's great as well. I guess on the flip side of that, what examples of failed stories you've seen and what can we learn from them? Lorena first.
Touching on the failure bit, what I really want to emphasise here as well is failure is a really important part of the process. It truly is, especially when we're talking about innovation and transformation. You need to be able to fail fast and regularly to be able to make sure that you're bringing the right product and you're matching the market where it's at. So what I would really like to emphasise there is you'll see failure all the time. We need to be creating that environment to allow that failure to happen, because the reality when you're going through these startup programs is you're creating a sandbox to be able to bring the reality to life in such a way that you need to be able to really pressure test it. You really need to be able to understand, is this technology correct? Is this the right product for the market? And how are we going to have the right impact socially, environmentally, across the scale that we're aiming to achieve. So you need to fail repeatedly to be able to do that correctly.
Yeah, no, for sure. And James, I think on that as well, knowing that failure is also important to success. Do you have any stories for that and experiences that companies can learn from?
That companies don't do well?
From failed companies and then, maybe success after that.
Okay. If you're talking about companies that have crossed a chasm, that have maybe not do well and then now all of a sudden find a product market fit and so on, there are many. I think one of the challenge that we always see for companies is, even in Liveability challenge would be, they're so focused on the technology, they're so focused on solving some particular environmental factor and so on, that they totally ignore that the business itself needs to be sustainable as a going concern. And besides the fantastic grants or winning amount that the Liveability Challenge and all the other kind of grants that Singapore gives, this business has to be sustainable. And we've seen many of them, like Alchemy Food Tech that I mentioned, they have received grants, winning competitions and gone on to be successful, but they weren't always that way. They really needed to focus on the commercial aspects. And this is something that I'm hoping that Turtle Labs and so on will do so.
No, of course, and of course we wish all the best for the finalists here today as well. I think on that note, I'm going to take some questions from the audience, both in person and virtual as well. So from an in-person audience, if you have any questions, please feel free to scan the QR codes beside the stages and let me know. Well, not let me know, I guess let the system know, and I will get the questions to pose to the panelists. But while that's happening, I actually have a couple of questions already on my side. Actually, a question for Lorena. We know that Microsoft has quite ambitious targets, sustainability targets as well. So how's the pledge going to eliminate all of the company's historic carbon emissions going?
So where we at that? So that draws me to really explaining what our targets are about. So we have agreed to, or what we are aiming to be is carbon negative, waste zero, water positive, and have a planetary computer, all by 2030. And we just announced those in early 2020 ourselves. And for myself as a sustainability professional, what is so exciting about working in a company like Microsoft is that it sets that accountability, that ambition, and it is a moonshot for the company. We do openly call it our moonshot. And what that means is we're 18 months in the journey ourselves, and we are progressing on towards that. So what you will see is a lot of announcements that are coming through around our renewable pledge around 2025 to have all our data centres be 100% on renewable energy by 2025. You'll also see as part of our carbon announcements, especially because that is our, I guess you can say, our most mature out of all the announcements, we have also seen a series of announcements of what we're doing also from our operations. So you start to see KPIs coming through for leadership this year, but also some of the products and services that we're providing to our customers. So literally last week, we announced our cloud for sustainability, which is a sustainability cloud 100% geared for enterprises, as well as what scenarios that we saw today, that allows for that scope 3 emission tracking, that allows for that enablement of end-to-end transformation, and all the features that we need to be able to enable our carbon pledge. So we are at the very beginning of our journey. We have a long way to go. You'll also see a lot of Brad and Lucas talking very openly about some of the strategies we tried that might not have worked and we need to adjust. But the short answer is we are definitely on our road on the 2030 pledge, and we are adjusting as we go, and certainly releasing more and more products, technology, and applying more to our operations as we proceed going forward.
Oh, that's great to hear. And I guess as a follow-up to that, and also with regards to your Microsoft Sustainability Innovation Program as well, what does Microsoft seek to, kind of find from that program, and how it can help you, whether that's going to help you as well in your decarbonization processes?
Yeah, and I think the best way to come to it was also coming onto the innovation. What does the innovation mean for us as well in this space around sustainability? And, when you look at all our strategies, they're all geared around what we need to be doing to solve some of the biggest challenges that we have. And it's all grounded in our mission around empowering everybody on this planet to do more. So for us, innovation really comes down into the co-innovation. So how do we enable, or how do we allow for our technology, our platforms, and our ecosystems to be available very broadly to our customers, our partners, and also startups, as you saw today, to be able to allow for that co-innovation. And that is the most critical part of what we need to do. And what you saw today in the spirit as well is we need to allow for that dialogue. We need to allow for that sandboxing. We need to allow for these environments to be open so that the right co-innovation can take place. We can find the right solutions that we have for the enormous challenge that we have in front of us. And we also, what we need to be also creating in this kind of environment is that juxtaposition between business, enterprise, community, social, but also governance as well, and how we're working with our governments in this space.
No, that's great. Thank you so much for that, Lorena. I'm not sure, James, if you had anything, you had a very thoughtful expression, so I was wondering if any comments on that.
No, Microsoft moves things at scale. But you got to remember, it's a very, very big company. So in terms of execution, it's amazing how they can move the different pieces in Microsoft to get this thing done. So it's amazing.
Yeah, no, it really is. But thank you so much for that, Lorena. I guess for James, in terms of the investment perspective, how do you suggest that investors adjust their models to accommodate the longer-term horizon and volatility?
Well, in our investments, we have not found a need to adjust anything, if at all. It will be to incorporate ESG measurement factors, but it doesn't require any compromise on any other factors such as compliance, such as returns. Nothing has changed except adding more factors for consideration before any investment is made. Yeah.
Okay. Now that's good to hear as well. That's what to be done, I guess. I guess on that front, Lorena, what type of companies are Microsoft seeking to invest in to reach its aim to be carbon negative by 2030?
say it's not so much companies per se, it's more characteristics that we look for. Obviously, we've got priorities around carbon, being carbon negative, and as you can see across our water, so water and waste programs as well in particular. But it's more the characteristics that we look for. We do have a climate innovation fund that is available. It's a $1 billion fund that we do have. You'll see various investments that have already taken place around the globe in this space. And what this fund looks for is obviously positive impact, the risk that's involved, and also the return on investment. But what we also need to be looking at is it needs to be providing a specific solution. It also needs to be able to be innovative and scalable. So it's more the characteristics that we look for in terms of the kind of companies that we invest. And in fact, when you look at a lot of the startups that presented, they represented a lot of these characteristics. And I think that's one of the key challenges is finalising who you will be going for, what is the right business model, and where is the right match in that environment to provide the solutions that we need.
Thank you for that. I'm just going to ask you both one more question, actually, because the judges are here are ready to deliberate on to announce actually their winners. So before we end, I guess one more question is that what is one piece of advice you have for companies looking to achieve sustainability, impact, and success at the same time?
Go ahead.
James, you can go first.
What is the one company?
One piece of advice that you have for companies looking to achieve sustainability, impact, and success?
Can I use eco-business as an example?
Sure, of course.
I think eco-business really scaled up when Jessica hired the right people. I mean, take you as an example. You came in with a legal background. So it's necessary and important to make sure that just because we're driving something new doesn't mean we always have to be living in a startup mode. In order to scale, we got to hire the right talent. And you need to hire from the industry,
Thank you for that. And then Lorena.
Just to confirm, you were asking what our piece of advice on sustainability.
Yeah, one piece of advice.
Okay, great, thanks. You know, I think sustainability is part of transformation, both from a business model transformation and a technology transformation point of view. So what my biggest piece of advice to companies is I encourage you to make it core to your sustainability strategies. Make sure that it's fully integrated into your operations, but also from a non-technical point of view, it's about people. Everyone remembers the technology, but you need to bring everybody in your organisation along with you on this journey to make this successful. So that's one of the biggest pieces that I would say to many companies on their sustainability journey. And just begin, because we're at the start of the journey. There is a long way to go, and the best piece you can do is just begin, take the first step forward. Don't wait to see what others are doing before you start, because it is absolutely imperative that we start having impact in this space.
Thank you both, Lorena and James, for your insightful discussion and comments as well. And thank you everyone for contributing such good questions as well to our panelists. In closing, we've covered really interesting insights around sustainability and innovation and the role of investors, businesses, and consumers in the road towards achieving sustainability and impact at scale. I'm sure we can all conclude that the current world we live in presents quite unique opportunities to accelerate progress towards new sustainable, innovative practices. Consumers are demanding better from businesses, and stakeholders have increased expectations towards contributions and sustainability. It is clear that businesses cannot operate in the way they did before, and that innovation for sustainability is key to longevity. On this note, we've come to the end of the panel session. Thank you again, James and Lorena, for making the time, and thank you everyone for tuning in. We now come to the part that everyone is waiting for, the unveiling of the Liveability Challenge Grand Finale winners.
Thank you very much, Megan, Lorena, and James. Please, another round of applause for our panelists and moderator for the most insightful discussion. Thank you very much. And I also like to welcome our judges back to the room. It's been a very exciting 45 minutes as the judges deliberated on the results. To our audience, please continue sharing your thoughts and your questions with us as we move into the final segment of the event. After those pitches that we've heard today, I'm sure the judges have some thoughts and feedback for our teams. So I now like to invite the teams back to stage as well as the judges to give their feedback. And we are going to start off with Econic and Patty. Over to you. We'll wait for, yes, there you go. Michael's here.
Hi, Michael. Thanks for the presentation and thanks for clarifying my questions. I really like the fact that it is you've thought of the whole life cycle of the product, fully recyclable catalyst as well. The fact that compared to a larger, I guess the capex needed for retrofitting is much lower. That starting a whole new company, I guess, from an impact or decarbonization point of view, maybe the one thing that I feel like it's still quite dependent on fossil fuels, the product, and I understand. I mean, plastic is still extremely useful, and we can't change that from one day to another. But that's my feedback for now. Thanks.
Thank you, Patty. Michael, you have a response? Oh, no.
Am I still here? Yeah.
Yes.
Thank you. That's really helpful feedback. I agree that plastics, as they are now, we still need to use them. They have extremely valuable properties, particularly in areas like insulation and mattresses, where we can get better night's sleep and enable our houses and our buildings to be more energy efficient. In the future, we'll obviously be developing the technology to be less petrochemical based, but as a good starting point, we can enable the current supply chain to reduce their carbon emissions and use waste CO2 as a raw material, which is a good place to start for a complex and heavily regulated supply chain.
Thank you so much, Michael, and thank you, Patty. We'll now move on to the second team, and that's SEPPURE. If I could invite SEPPURE to come on stage, and I believe John has some feedback for you.
Great. Well, thank you both for your presentation. It was really insightful. I actually have some friends who I think know you guys well and are investors in the company, and I'd heard many, many good things about you even before the competition. But I think really you speak for yourselves. A very, very strong team, very, very technically capable, huge opportunity. I think I'm not personally an expert on membranes, but I think one thing we were discussing a little bit was that in the presentation materials, it's very compelling, obviously, to look at this versus other solutions that are out there versus some more traditional solutions versus other membranes. But again, I think by all accounts, it's very compelling, the efficiency improvements. I also like the approach, that if there's a beachhead, you have a very specific targeted use case to start with, but then there's a very big opportunity to go into other types of oils and other types of solvents. So yeah, really just very impressed, and really appreciate all of your time and effort here.
Thank you so much.
Thank you. Any other responses?
I just need to say thank you. Yeah.
Thank you so much, SEPPURE. And now I'd like to invite the next team on. SeaChange, who's going to be joining us virtually. Yes, that's right. And over to you, Steve.
Hi, Gaurav. Hi, Kamali. And thanks again for a great presentation. Some of the things we really liked about the presentation were there's a very exciting project, a big, bold, novel approach to carbon capture. The potential for impact is huge, using oceans to absorb CO2. We were impressed by the team you had on display, And one of the things we really liked was the strong Singapore synergy, particularly with PUB and the desalination plants and the ability to leverage desalination plants. Areas that perhaps we've had a little bit some concerns for is obviously, clearly this is a very early stage technology and still largely unproven. The investment required, I guess, if we're not able to leverage existing infrastructure, and then also a little bit around the unit economics with current and short-term carbon credit pricing. But overall, great presentation, and really enjoyed it. So thank you.
Thank you, Steve. Any comments?
Oh, no comments. Thanks very much, Steve.
Thank you very much, SeaChange. I'd now like to invite the next group up, and that will be Aegis Packaging. Mr. Lim, over to you.
Well, Kai Liang and Dr. Ong, thank you very much for a very good presentation. I think you are in a good space where everybody is looking for sustainable, biodegradable packaging. I think currently there are probably one or two other competitors in this space, but like you, none of them are sort of a fully commercial output scale yet, And therefore, you have a good window. You are already, O2X is already ready to roll. And I think you will have a good time of maybe 5 years where before the other products will compete with you head on. But you are in a happy situation because the demand for sustainable packaging is much, much higher than the supply that is currently available. So I wish you success as you capture this space. Thank you.
Thank you very much.
Thank you, finalists. If that's all, then okay, we'll move on to the next one. And the next one is Divi Gas. Invite Ali up on stage as well as Alice on screen. Oh, and Andre as well. I think you're on mute, Andre, just so you know. And Alice, over to you.
Hi again, and thank you again for a wonderful presentation. I think you went up in everybody's estimation based on today's presentation and indeed the answers to our questions. I think also just to highlight, I think what's incredibly credible about your company is that you've developed a really strong team. So you have somebody with the expertise who, of course, has invented the solution, but then you have somebody with the expertise who knows how to take a startup all the way. So I think that was very, very impressive. I also thought that you had very good awareness of how to grow the company. I like the fact that you've already identified 8 pilots that you're going to undertake to demonstrate the capability of the product in a variety of different locations and geographies. So that, of course, will appeal to a wide selection of clients across the world. So I think you're doing a great job. And I think just to reiterate, you went up in everybody's estimations based on the presentation and your answers to questions. Thank you very much, everyone.
Thank you, Alice.
Thank you very much.
Okay, thank you. We'll move on to the next team. Last but not least, we'll invite New Battery Materials up on stage and to get your feedback from John.
Thanks very much again, gentlemen. Wonderful presentation. Yeah, I just want to say it was very impressed, and I think it's interesting that this is a problem that is very kind of familiar to everybody because it touches EVs, which is quite a consumer play, but at the same time, the sort of solution is hitting more in B2B and upstream in the supply chain, where potentially there's much sort of broader impact. I really liked, I asked the question about China. I actually like the China story. I mean, China is obviously a very, very, very big market and very sort of at the forefront of what's taking place in the EV industry. I like that it's there's some control and you're doing some of your own manufacturing, but the partnerships with the recycling plants allows it to be a little bit more capital efficient than if you were to start everything, deal with logistics and so forth. And I guess lastly, I'll just say that, as a VC, when I invest, I'm always looking for this X factor. You can always put things in spreadsheets when you're investing in public companies, but in early stage companies, it's hard. There's just something, that X factor that you need to look out for. And I got to say, with the two of you guys, I just really felt that that was there. There's something about you that is just very endearing. I just really want you to win somehow. So, yeah, really, thank you again for all your contributions and the work you're doing.
Thank you, John.
Yeah.
Thank you so much, John. You guys have the X factor. Okay, thank you so much, team. And I would now invite the two of you to take your seats. Thank you, judges, for all your insights, and thank you to all the teams as well, whom I'm sure they will find your feedback very useful on their journey to success. And now we have finally reached the moment that we are all waiting for, the unveiling of our prizes and our winners. I have to say that this has been a very difficult decision for the judges, which is why they spent a considerable amount of time deliberating. And I guess we'll find out very soon. But before we go into that, following the TLC tradition, I'd like to say a few words about the trophies that we are awarding to our finalists. And you can see them there lightly shining at the side of our stage. It's made by local company Roger & Sons, and it embodies the spirits of innovation and inspiration. The awards are handcrafted from recycled angsana wood and crowned with a light bulb representing the brightest of ideas. All the finalist teams will be getting these delivered to them after the finale. Right, so first up, we are going to unveil the results of our popular poll as voted by you, our audience. And all right, the winner of the popular vote goes to Aegis Packaging. Congratulations, Aegis Packaging. We'll just trouble you gentlemen to take a photo with us, with me actually. Yes, okay. Thank you so much, gentlemen. I invite you to take a seat. All right, moving on to the next award today. We will be presenting the award by AmAsia. And I have good news for you guys because John has decided to increase his award. He was so impressed by all of you that he's going to get 2 prizes now of 50,000 investments each. And John, I'd now like to invite you on stage to join me. Thank you, John. Okay, so we're going to announce the first of the 2. And if I can get some suspense here. The first winner of the AmAsia Award goes to SEPPURE. Congratulations, SEPPURE, for winning this award. I'd like to invite you on stage. You can take a photo. Congratulations, SEPPURE. I'd like you to take your seat now. And if we can give John the second award. And we'll invite John back on stage for the second one. Sorry to have to make you do this twice now. And okay. The second award from AmAsia goes to Divi Gas. Congratulations, Divi Gas, for winning the second award from AmAsia. Thank you very John. Thank you very much, Divi Gas. Okay. Next, we will be presenting the prize from Silverstrand Capital. And this is a $50,000 investment, and I'd like to invite Patty up on stage to present this award. Thank you, Patty, for joining us on stage. Okay. And the Silverstrand Capital Award goes to New Battery Materials. Congratulations, New Battery. Please come up to receive your award. Huge congratulations. We'll now take a photo. Thank you very much, Patty and New Battery Materials. Next up, we have the prize from Planet Rise. And Steve had, at the start of this event, increased his investment to $100,000. And I'd like to invite Steve now on stage to present the award. Okay, the suspense continues. Yes, thank you. All right, so the winner of the Planet Rise Award goes to Sapio. Congratulations, Sapio, on your second award. Big smiles, gentlemen. We can see your smiling eyes behind the masks. Thank you very much. Thank you. Okay. We've come now to the most highly anticipated moment. The question that we've been asking, who will win the $1 million in funding? For this, I'd now like to invite Mr. Lim on stage for the unveiling of the 2021 TLC winner. Okay, I get always very nervous at this stage because I always worry that I dropped the envelope or something. But we're going to announce now the Liveability Challenge winner for 2021. Let's have the drum roll, please. The Liveability Challenge grand winner for 2021 goes to SeaChange. Congratulations, SeaChange, for winning the award. Temasek Foundation has decided to award you the $1 million in funding, and it would seem that your distance has not really deterred you guys, so huge congratulations. Yes. All right. Mr. Lim, I'd now like you to share a few words as to why SeaChange is this year's winner.
Well, first of all, I want to congratulate all the finalists. You're all winners. Secondly, as Jessica alluded to, it was a difficult decision. To say that there were two proposals that were very close is an understatement. In fact, the first two were very close, and the judges had to have a couple of rounds of voting before we finally selected SeaChange. And I think one of the reason we selected SeaChange is because it's the impact it will create when it's successfully commercialized and implemented. It's a transformational solution that removes gigatons of carbon from the air. One of the other presenters has alluded to the fact that if it's carbon sequestration, you have problem of leakages and so on, but SeaChange solution to store them as carbonate, which can then be used for a landfill reclamation or used in concrete, is quite a permanent solution. And thirdly, we consider the fact that when used in a context, together in the context of a desalination plant, there's a lot of synergy, and the costs will be reduced, and it makes it even more viable. And today, we are beginning to realize that water will be the next oil, and countries will go to war over water. So it's a matter of time before many other countries begin to have desalination plant in order to have enough water. And this solution will be in time for such a situation. So for all these various reasons, we have selected SeaChange as the winner of the 2021 Liveability Challenge. And congratulations to you, Gaurav.
Thank you so much, Mr. Lim. Thank you. I now like to invite Gaurav and Kamli for your thoughts on winning the 2021 challenge.
Well, thanks very much, Jessica. Of course, it's great to win, but first of all, congratulations to all of the other finalists as well. Our thanks to the Temasek Foundation, thanks to the judges for selecting us. You know, I think lots of what Mr. Lim said is exactly spot on, and you know, this is how we feel as well. This is important work. Obviously, it has the potential to be transformative, and support of the sort that you are providing, I think, is fundamentally necessary for us to really accomplish what we want to do. With that said, it's always great to win, so thanks very much.
Thank you. Kamli, would you like to add anything?
Sure. I mean, I'm completely surprised, and it's been a great experience. I thank you and your team for all the helpful feedback and getting us here, and congratulations to all the finalists, and thank you again for choosing SeaChange.
Thank you. I guess we'll be seeing you in Singapore very soon, the both of you. Thank you so much. Thank you so much, and congratulations once again. See you.
Thank you so much.
I'd like to now thank once again all the finalist teams on all your hard work and your wonderful ideas. I would like to add that this is really only the beginning of your journey, and I'm sure that you will all be attracting investments beyond those awarded this afternoon. There are many, many VCs and investors here among our audience, and even if you weren't awarded a prize here today by the judges, I'm sure you have attracted a lot more interest. I want to also thank all the judges and those who have joined us from different time zones to make this event possible, and we will definitely be following up with you in the weeks to come. Now that we have come to the end of this exciting finale, I'd like to say a few thank yous to our judges, Mr. Lim, Patty, John, Steve, and Alice, joining us all the way from Geneva, even though it's so early. Thank you for being with us and sharing your experience as well as your knowledge, and by walking the talk and putting capital into these projects. This event would also not have been possible without the support of our amazing partners, some 70 organizations from across the world who have been part of our journey. You can see all of them behind our strategic partners, our challenge partners, our outreach partners. There are too many for me to name them, so I hope you forgive me. Otherwise, we'll be here till midnight. And our community and communications partners. A huge thank you to all of you. And most importantly, to Temasek Foundation for your vision and partnership in this important initiative. I'd also like to express my gratitude to the teams at Temasek Foundation, Ecobusiness and Marina Bay Sands, and all the crew here who have worked tirelessly to bring you this event despite the changing regulations that the government kept throwing at us. We're very happy to be able to host this in person, and really thank all of you who have been here with us today in the studio, and also all of our virtual guests who have joined us. I hope you enjoyed it as much as we did and have been inspired by the solutions. Our global quest for the best sustainability ideas will continue, so keep them coming. Do help us to spread the word about TLC by posting to your networks with the hashtag TLC2021. Please look out for the next edition of the Liveability Challenge. Until next time, see you.